Welcome friends, I'm so glad you're here. Whether drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, this is a soft place to rest. Perhaps someone listens from a city balcony after rain. Perhaps another lies near a small window where night air moves like a slow tide. Wherever they are, they settle into warmth and breathe. If peace or curiosity rises in these gentle stories, a quiet sign of support passes along the way, and to those already travelling with these night journeys there is a small, steady thank you. The voice moves without hurry into a region of sky outlined by old patterns, the constellation Virgo, a field of sparse stars and faint diffuse clouds of unresolved light. In this dark pasture, a single point gleams with the tidy sharpness of a star, yet it is not a star. It holds steady, white and cool to the eye while the world turns, while the rooftops breathe, while ocean swells roll their uncounted miles. Under a modest telescope it remains a point untroubled by size or shape, and that smallness is the first quiet irony. It looks like very little, yet its light overpowers the collective starlight of a massive galaxy that holds it. Another irony follows. Close behind the point seems near because it is crisp, but its light left when mountains on Earth wore different rivers a journey across billions of years that arrives as something simple and immediate, as if it had only just begun. And a third soft irony rests beneath both. What appears constant in the eyepiece actually flickers on human timescales, a few percent from month to month, the pulse of processes too large to see and too compact to resolve. The point has a catalogue name 3C273, an entry first gathered for its radio voice. But here in the calm of Virgo's starfields, it presents itself by sight alone, lighthouse bright against a sea of darkness. A scientifically accepted fact gives foundation to the scene. This point marks a quasar, an active galactic nucleus energized by matter, falling toward a supermassive black hole, where gravitational potential turns with astonishing efficiency into radiation bathing space in ultraviolet X-rays and the visible tones that reach a small backyard mirror on Earth. The quiet physics remains spare and elemental. Gas dust magnetic fields gravity. A disk forms because angular momentum resists straight paths. Friction and turbulence within that disk heat the infalling gas until it glows blue-white, while above the disk a hot tenuous corona scatters light to higher energies. The result is brightness out of proportion to scale, a compact engine shining with the power of 1 trillion suns within a space no larger than a solar system, a furnace whose edges cannot be seen, only inferred by how rapidly it changes and how swiftly its light echoes from the broad line clouds that surround it. A lesser-known real-world detail flickers at the margin of this view. Under especially transparent nights, and with modest amateur instruments, small glass, carefully collimated, patient eyes, this quasar becomes one of the few known extragalactic nuclei that a person can see as a point with their own equipment, a private confirmation that the distant universe is not an abstraction, but a direct visitor in the quiet of a backyard. The eyepiece anchors the present, but the mind drifts outward along the ray of light itself, a filament that threads the interstellar medium of its host, galaxy, crosses the thin gas between galaxies, slips past warm halos around clustered mass, and arrives through the layered air above oceans and forests. The universe along this line of sight remains mostly empty, yet even emptiness carries a texture, a haze of tenuous hydrogen, scattered ions and dust grains that leave faint narrow signatures in the spectrum, small notches that map the otherwise invisible architecture between clusters and voids. The seeing continues to slow. In the imagination the point enlarges without breaking its discipline, the way a city seen from far offshore resolves into lights before streets. The central engine remains hidden, but the structures around it appear in their roles without ornament. The accretion disk circles in near silence, each ring turning faster as it approaches the event horizon, radiation bleeding softly from spiral paths. Magnetic fields rise from the turning plasma and thread space, guiding some fraction of the infalling matter into a pair of narrow outflows jets that extend far from the nucleus, carving through the galaxies' thin atmospheres and painting lobes in radio maps. In images made by linking antennas across continents, small knots in one jet slither outward over years and appear to outrun light. Not because they do, but because geometry and timing allow changes in brightness to propagate in a way that mimics superluminal motion, a lesson in how perspective becomes a teacher when speed approaches the universal limit. The human eye cannot see those radio lobes tonight, nor the knots nor the rotating disk, but the point remains honest about what it can give a direct photon polished by time that left when continents on Earth wore other boundaries and ice moved differently across highlands. An uncertainty is allowed to remain as gentle mysteries should. Even now, with equations and simulations and long campaigns of observation, the exact coupling between the spinning black hole, the swirling disk, and the magnetic fields that build and collimate the jet is not fully closed. It is known in principle the energy lies in spin and in the shear of plasma. The fields can extract it and structure it, but the fine patterning of turbulence reconnection and the way particles gain their extraordinary energies retains an interior fog. Another uncertainty stays near the duty cycle of such engines: how long they shine, what switches them on, and lets them dim, how galaxy environment and inflow history choreograph their active phases across cosmological time. The voice of the narrator keeps level, but time itself supplies the atmosphere. Only took billions of years for this light to gather at the rim of a glass lens. Only took a deep well of gravity to turn falling gas into something that rivals small constellations. Only took the absence of size in an eyepiece to hide the larger scales a galaxy can host. In this first resting place, the script avoids the urge to tell a story, and instead lingers on the operational present light crossing space, energy changing form, a point revealing mass by the power it emits. The comparison that remains is mild and modern, not offered as wit, but as clarity. The nucleus breathes in matter and releases radiation, like a slow planetary exhale, pressure and flow, balanced by the quiet bookkeeping of gravity and heat. A nearby wind presses a curtain against a sill. The night holds. Beneath everything, the ground stores the day's warmth in stone and soil, and overhead the quasar's steadiness becomes a kind of clock that does not count seconds but ages, marking a time scale where months are weather in the engine room and 1,000 years are only one long observation. The view in Virgo is not spectacular to the unaided eye. There are richer lanes near the Milky Way, brighter stars in Orion, luminous knots in the Magellanic Clouds. Yet the quiet here serves the topic because the point that looks like almost nothing is an argument for patience. It proves that distance can be intimate, that a single ray can transport the record of structure formation, black hole growth, and the history of an entire host galaxy. It proves that a small instrument well used can meet the largest questions with the same humility as a great array, each collecting their photons and laying them out like river stones. It proves too that the universe permits both extremes at once, the narrow and the vast, the compact engine and the halo that extends for hundreds of thousands of light years, the instant of a flicker and the long drift of a jet through intergalactic medium. The light from 3C273 completes its way into the mind's eye, which holds it for a moment, labels it without hurry, and lets it rest as a plain sufficient fact, a quasar in Virgo, a beacon in the dark, a steady point that teaches scale by refusing to grow larger when magnified. The night deepens by a fraction that no one can measure. Air cools, water condenses on leaves, and the sky continues its slow turning. The point remains. The scene shifts without changing pace from a bright point in Virgo to a line in a registry where ink and patience once did the heavy lifting of discovery. A catalogue opens in the quiet of an office or a library or a radio hut long gone, and there the entry rests with no ambition to impress Third Cambridge Catalogue of Radio Sources number 273. The name is only a coordinate with context, a compass note stitched to a frequency band, but it carries the weight of a sky-wide harvest, gathered by antennas that listen where human eyes cannot. The accepted fact is plain and sufficient. 3C273 is a radio-loud quasar, a compact core that blazes across wavelengths and breathes power into extended radio structures, lobes that stand off from the host like distant lanterns fed by a narrow jet from the nucleus. The paper trail is careful. Observers map the radio sky in beams as wide as the moon, then return with finer instruments, trimming uncertainty step by step. Flux densities are measured positions, refined spectra assembled. A set of coordinates settles on a small patch of Virgo where the optical sky looks simple. The irony begins softly. A few millimeters of printed text typeset among hundreds of similar lines point to a source whose energy budget rivals the starlight of entire galaxies. Another dry observation follows that the radio name, born of survey grids and sensitivity curves, becomes more durable in memory than any poetic title could be, and a third, even drier, that a catalogue built to depersonalize the sky ends up turning attention towards some of the most individual objects known. The thread then pulls outward from ink to instrument. At radio wavelengths, the core appears bright and compact, but not alone. Far from the nucleus, diffuse lobes swell, where the jet, after long travel through the galaxy's thin atmosphere and into circumgalactic space, deposits momentum and magnetic fields into reservoirs of relativistic particles. Synchrotron radiation gives them voice electrons, spiral along field lines at near-light speed, and radiate across radio bands in a smooth power law hush. Between the core and the lobes, observers see brighter segments, a jet spine with knots that brighten and fade, each knot a site where shocks or reconnection thicken the local glow. Alignment matters, and the alignment holds the compact radio core, the optical point, the X-ray position, and the axis of the extended radio map share a geometry that ties the small to the large, the inner engine to the outer bloom. A lesser-known detail rests in the craftsmanship of the maps themselves. Long before baselines stretched continent to continent, early interferometers paired dishes across a few kilometers to sharpen sight using Earth's rotation as an unhurried lens polisher. Fringes those delicate interference patterns were counted in long overnight watches to tease sub-arc minute structure from a sky that to a single dish looked soft. From such counting grew positions good enough to guide optical plates to a star-like candidate, and to keep returning to it as the radio beam narrowed with each generation of array. There is patience in this ladder of precision, and a certain humility. Only took thousands of careful calibrations to arrive at a single coordinate. Only took decades of survey work to frame one bright point. Only took a global network to draw a line the width of a few light years across a galaxy, millions of light years away. The narrative remains level, and the physics stays elemental. In the core, gravitational energy from infalling matter converts into radiation with an efficiency that outpaces ordinary nuclear burning. In the jet, a mixture of ordered and tangled magnetic fields channel some of that energy into directed outflow, a collimated stream that remains narrow across parsecs before widening and fading. In the lobes, energy spreads into larger volumes and cools radiatively and adiabatically, becoming faint and old. Spectral indices, the way brightness changes with frequency, age like tree rings, steeper, far from the core where electrons have lost energy over long times in the field's embrace. If spectra flatten anew along the way, fresh acceleration must be working, another quiet clue that shocks and turbulence are sculptors here as well as couriers. A small persistent uncertainty sits at the centre of the page. The coupling that turns rotation and magnetic stress into a steadily collimated jet is understood in principle, yet remains model-dependent in practice. Simulations catch pieces of the flow disks that break into spirals, fields that thread horizons, plasmoids that bud and merge, yet resolution and microphysics leave gaps where experience and inference must meet. The dichotomy between radio loud and radio quiet, quasars too, keeps its private motive. Spin, magnetic flux, supply host environment, and accretion state all stand as plausible governors, with evidence pointing in several directions at once. The catalogue entry does not adjudicate. It simply names what is found to be bright at a given wavelength, and brightness alone never reveals cause. The dryness of survey language is a comfort, not a constraint. Numbers sit in neat columns, right, ascension, declination, flux, at 178 MHz spectral slope. Behind each number lies weather over a field station, maintenance of cryogenic receivers, phase, stability of local oscillators, and the nighttime patience of observers who let the sky rotate their baselines into a synthetic aperture. In later years, very long baseline interferometry knits entire continents into a single instrument. Millisecond structure appears. Components separate over months by fractions of a beam. Apparent superluminal motions enter the logbooks, a lesson in how near-light speeds and small viewing angles conspire with light travel time to suggest velocities forbidden by the same physics that shapes the jet in the first place. The core's brightness temperature, if naively inferred, violates inverse Compton limits. Doppler beaming arrives as the gentle fix a tilt and a speed that concentrate radiation into a narrow cone toward the observer. A standard candle this is not. Yet 3C 273, with its well-measured redshift and multi-wavelength completeness, becomes an anchor. In another sense, a calibrator, a reference point for amplitude and phase, a friendly constant in the drift of instrument upgrades. Arrays use it to check themselves. Cross-identifications rely on it to test astrometric alignment between catalogues. The name which began life as a survey label becomes a kind of quiet metronome for the community, ticking across decades of observation strategies and detector physics. The host galaxy stays behind the glare in this section, because the catalogue is agnostic about optical appearances. Even so, deep images, subtractions, and careful modelling eventually surface the underlying starlight, a luminous elliptical whose light profile swells smoothly, a broad background against which the nuclear point stands like a white pin. The catalogue does not say elliptical, but combined maps whisper it in their own way, since powerful straight jets and large radio lobes are frequent citizens of massive spheroids with big halos and ample room for hot gas to cushion a jet's long path. Between the core and the lobes lies a medium with a memory. Polarization maps show that fields are not random. There are preferred directions draped and stretched by motion. Faraday rotation marks the presence of magnetized plasma in and around the host, turning the plane of polarization by frequency-dependent angles that tell of density and field strength without ever needing a photograph. The jet reads that medium like a stylus on wax, leaving grooves of compressed gas and pockets of particle aging that can be traced long after the central engine changes its mood. A gentle analogy lingers without pressure. The catalogue line is like a thread in a loom, thin on its own, yet when crossed with thousands of others, it makes a fabric strong enough to carry the weight of an entire sky. With it, an object that looks point-like in a small optic gains a scaffold of context beam shapes, baseline lengths, spectral windows, calibration sources that allow the point to become a system. The data-month variability noted in light curves that ignore weather and seasons as best they can offers size limits through light travel time arguments, while the long, slow fading of remote lobes offers age limits that count in tens of millions of years. Time flows in two registers at once, the fast clock of the compact core and the slow clock of structures spread across the host's outskirts. Only took a few nights to see the core flicker. Only took a few tens of millions of years for the lobes to fill and dim. Only takes an instant now for both stories to be true in the same field. The outline of this project keeps to its vow of gentle continuity. The catalogue's spare language remains, the quasar continues to shine, and the Virgo field still looks uncomplicated until instruments translate it into its radio self, where structure is everywhere. No verdicts are needed. It is enough that the dry line labelled 3C273 opens into a layered object, whose compact engine and wide wings move together in quiet equilibrium. The page could close here, and the sky would remain unchanged, the lobes still faint at meter wavelengths, the core still bright at centimetre and millimetre bands, the optical point still small and unwavering. A record in a ledger, a lighthouse in Virgo, a geometry that binds the central bright dot to the far soft embers flung outward by long labour. This is the meaning hidden inside a name that began as a number. The moon approaches like a quiet edge, a moving horizon that writes a straight line across the radio sky. It does not hurry. Its limb drifts at a steady pace set by orbital mechanics and geometry, a half-degree disk crossing background sources one after another, letting each brighten or fade as if someone slowly draws a curtain. A fact stands at the centre of this scene and holds a lunar occultation. When the moon slides in front of a distant emitter, turns the lunar limb into a measuring blade, and from the pattern of disappearance and reappearance, from the timing and the fine ripples of diffraction, observers derive a position for the source far more precise than their dishes alone can give. In that blade's passage, the radio voice of 3C273 trims and then returns, and from those clean cuts the sky receives a pinpoint coordinate. There is a small office somewhere with paper that remembers this. On the forms, times are written with care the moment the signal drops, the moment it resumes the intervals between the bright and dark fringes, as the moon's rough edge diffracts radio waves into a brief lace of light and shadow. The telescope listens, the recorder ticks, and the limb keeps sliding. The method is patient and almost modest. No global interferometer, no continent-spanning baselines, just the nearest world in the sky, lending its edge so that astronomers can draw an exact cross on a map. 3 soft ironies arrive together and leave no disturbance. The nearest object in the night becomes the finest ruler for one of the farthest. The brightest lighthouse in Virgo is located because it disappears, and the moon, which usually scatters radio noise and reflects sunlight into the eye, helps by being blank, its silence sharpening the source behind it. A lesser-known detail takes a place in the slow narrative. The occultation traces not a single boundary, but a kind of fingerprint of the lunar limb, because mountains and craters along that limb give the diffraction pattern a structure of its own. By analysing that structure, observers extract sub-arc second precision from instruments whose beams would otherwise blur the source into a featureless knot. The moon, without intending anything, acts as a moving knife edge and a moving aperture, its ragged silhouette turning Earth's rotation and lunar motion into a long, unrolled interferogram. The technique is old in principle and exacting in practice. Ahead of time, ephemerides are computed, the telescope is pointed to where the moon and the radio source will stack. Receivers are cooled, calibrations are refreshed, clocks are agreed upon down to small fractions of a second. When the moment comes, the recorders run the limb approaches, and 3C273's flux density dips into the fringe pattern, then falls. From this fall, and its echoes, a compact position is calculated, and a search rectangle shrinks on the optical plates to a small region, where the eye scholar and patient looks again. The chosen field is not dramatic. Stars dot the emulsion like tiny beads, yet there almost at once, when given the correct crosshairs, is a point as sharp as any 12th or 13th magnitude star. A faint streak of nebulosity lies nearby, thin and slightly curved, the hint of an optical jet that will later take its place alongside the radio story. But in this moment, the practical triumph is simply positional. The radio and the optical now share a single coordinate. The air in the control room remains ordinary. Papers do not flutter with revelation. The tape keeps turning. Only took the moon's path to resolve a position. Only took a few minutes of occultation to supply what months of standalone beam mapping could not. Only took the absence of light to show where to look for the source of so much light. The physics beneath the method stays quiet and sure. Fresnel diffraction governs the fine structure of the signal, as the sharp boundary of the lunar limb moves across a coherent wavefront. The characteristic scale of those fringes depends on the wavelength and the geometry, and by fitting the recorded patterns one infers where along the limb the source sits, and how sharp its image must be. If the source were extended, the fringes would smear. Because the fringes remain crisp on short timescales, the emitting region must be compact. This inference size from the shape of fading light joins the collection of constraints built elsewhere, from variability, from brightness temperatures, from reverberation delays in broad-line clouds. A narrow converging picture forms not by any single device, but by how each device admits the others. The Moon's limb also tells a human-scale story of timing. The rate of the occultation traces both lunar motion and projection effects. The precise second when the signal vanishes depends on local seeing. In radio space, the limb profile small atmospheric delay system phase. Clocks are compared. Drift is corrected. A standard emerges from daily practice. A radio source that once sprawled inside a beam larger than a city block becomes by this moving edge a coordinate that an optical plate can honour. The night widens at the thought that a stone world only 250,000 miles away provides leverage on a quasar more than 1 billion light-years distant. There is a soft mystery still. Even with an exact position, even with an optical counterpart on a plate, the nature of the point remains at this stage disarmingly star-like. It does not show the dim swirl of a disk galaxy, or the fluff of a spiral. It sits like a star with a small adjacent streak. The spectrum, not yet measured in this section, will carry the decisive surprise and the exact way that broad emission line regions arrange themselves in depth and density around the nucleus remains an interior fog. The occultation gives where to look. It does not tell why the light is what it is. Another associated uncertainty lingers in miniature. The roughness of the lunar limb must be modelled to read the fringes with the highest fidelity, and limb profiles evolve as libration and viewpoint change. Observers fold that complexity into their fits, and still accept that a small residue of ambiguity comes along for the ride. Calm returns to the equipment and the record. The occultation passes, the source reappears. The Moon continues into its old familiar phases with no sign of what it has just enabled. The radio team posts the position, the optical team examines plates with a narrowed target in mind, and the literature in steady paragraphs records how a method that is conceptually simple, let the Moon cut the signal, unlocks a coordinate chain that ties radio to visible, visible to ultraviolet, ultraviolet to X-ray. This is a ladder made from minutes and from the discipline of clocks. The same Moon that tugs at ocean tides and lifts a crust by millimeters each day now serves as a transit knife for waves that once threaded the intergalactic medium. A gentle analogy rests without pushing. The limb is like the clean edge of a caliper in a metal shop, slid across a piece to find its exact centre, except the shop is the night, and the piece is a field of sky where most objects will never care about the measurement. The rest of the system acknowledges the result in its own languages. In astrometry, the cross-identification firmed by the occultation decreases the risk of mismatching radio lobes to wrong optical counterparts. In instrumentation, the event tests receivers' timing chains and reduction codes against the sharp transitions provided by the Moon. In planning, the technique selects other targets along the lunar path, because the ecliptic is a highway of potential occultations, and each one can deliver a position better than the beam and the day's atmosphere alone. The section breathes more slowly as the image settles, the lunar limb drifting the radio trace stepping down through fringes, the clean loss, the quiet reappearance, the plotting of a point on a plate, the recognition of a star-like object in roughly the right place. Only took a world moving in its regular way to tighten the whole sky along one line. Only took the patience to watch a signal go away and return to collect the proof of where it came from. Only takes the same method repeated to lay down a net of positions that future arrays and spacecraft will adopt as their own scaffolding. Down on Earth, the routine continues. The dish slews to a calibrator. The Moon recedes into a more ordinary role. The notebooks grow another page. Someone initials a margin. Up in Virgo, nothing changes. The jet keeps its motion along its narrow axis. The core flickers a little. The host galaxy holds its wide profile. The radio lobes far away from the core do not know that their parent source has just been nailed to the optical sky with fresh exactness. The light that will later give up its redshift has already long been en route. The technique has a short clock. The quasar keeps a longer one, and both clocks ticking together have now carved a shared coordinate where telescopes can agree to meet. The quasar remains small in the eyepiece. The moon, even when it leaves, keeps the authority of an instrument used well. The straight edge it provided lingers as a feeling more than a sight, that clean sense of position, that confidence that a bright distant engine has acquired an address precise enough for the next question to stand on. The scene holds steady, an Earth-Moon Virgo alignment written into records and memory, a tool made of motion that extracts a still point from a drifting sky. A slit crosses the small bright point and light becomes a length. Glass and aluminum, grating and camera turn whiteness into a band where colours arrange themselves by wavelength, and in that band dark and bright features step forward like markings on a ruler. The accepted fact stands calmly at the centre. The optical spectrum of 3C273 shows broad hydrogen. Balmer emission lines shifted to longer wavelengths by a precise factor. A redshift that places the source far beyond the Milky Way and into the Hubble flow, so that distance is read not by parallax or candle, but by expansion itself. The band is quiet until the lines arrive wide as river mouths with shoulders that speak of gas moving at thousands of kilometres per second around a mass that does not announce itself except by gravity's bookkeeping. They are familiar lines, H-alpha, H-beta companions in laboratory lamps and student exercises, yet they sit wrong if one insists on local expectations. They fit perfectly if one allows the universe to stretch them on the way. Hydrogen, the simplest atom, becomes a cosmological witness. A lesser-known detail rides along with this staid scene. The useful spectrum is not a single exposure, but a careful stack of Knight's calibrations and plate solutions assembled in an era when image tubes and photographic emulsions were still standard at large telescopes. Comparison lamps leave their fine comb of lines on either side of the quasar trace. A spectrophotometric standard star observed nearby in time and hour angle anchors the instrument's response. The slit is aligned to catch both the star-like nucleus, and if fortune and angle allow a faint wisp, a few arc-seconds away, the optical jet that later becomes its own small literature, so that the night sky, the calibrator, the jet, and the nucleus all leave their thin signatures side by side. The work is pedestrian. In the best sense, exposures opened and closed shutters that behave a dome that turns just so. Only took a set of routine tasks to answer a question large enough to disorient. Only took the lines every physics classroom already names to measure a distance that no human journey could attempt. Only took the discipline of wavelength calibration to turn a star-like speck into a galaxy-scale engine resting billions of light-years away. The section lingers over the way a line becomes a distance. In an expanding universe, wavelengths carry a memory of the scale factor when they left their source. Redshift is simply the record of that ratio. If the shift is z, the observed wavelengths are longer by a factor of 1 plus z, and in that number lives a ladder-measured shift to recessional velocity in the nearby universe, velocity to distance by a constant that itself comes from other independent rungs. For a quasar, the nearby approximation is not the full story, so one translates with a cosmology rather than a straight line, yet the principle remains the lines mean distance, because space itself has stretched while the photons travelled. The spectrum offers more than position along the ladder. Its breadths and asymmetries whisper about structure near the nucleus. The broad line region is not a single ring, but a stratified volume of gas ionized and reprocessing light from the accretion disk and its hot corona. Closer in lines are wider because gravity deepens and orbital speeds rise. Farther out lines narrow and delays stretch. Subsequent reverberation mapping will watch small echoes in these lines as the continuum brightens and dims, turning time into a ruler that weighs the black hole. But tonight the emphasis is simpler. Hydrogen's bright mouths sit where hydrogen should sit. If the whole spectrum has slid redward by a fixed, consistent amount, a soft mystery is allowed to remain in place because the script has no interest in pretending closure where none exists. Even with identification secure and redshift measured, the microphysics of the broadline region keeps part of its interior in shadow. The exact geometry, clouds or winds disks or spheroids, inflow or outflow components, varies in models and in individual objects. Line ratios depend on density, ionizing spectrum and dust in ways that still invite adjustment when codes meet data. The observed soft X-ray excess in many luminous quasars, including this one, asks whether the corona glows simply or in layers. The slope between ultraviolet and X-ray bands asks whether Comptonization has a single temperature or a spread. Those questions do not threaten the distance. They simply leave room for modesty about the engine's detailed architecture. The spectrum is viewed again this time with the small ironies turned up to the quiet edge of hearing. The first is that the universe's most luminous steady beacons are confirmed to be far because their hydrogen looks like lab hydrogen, only slid a cosmic result drawn with an element that burns in fluorescent tubes and faint nebulae alike. The second is that a line that once served to teach freshman optics with diffraction gratings in bright rooms becomes the signature by which astronomers agreed that active galactic nuclei are not local oddities, but cosmological citizens. The third is that the measure of distance here is not how much light has faded as with candles, but how much space has stretched so the very medium through which the photons travel carries the yardstick. The path marks itself. Around the central fact, other elements take their places without noise. The continuum rises into the ultraviolet where a thermal bump from the accretion disk contributes. In the infrared dust that has seen the nucleus re-radiate smooth and warm, narrow forbidden lines sit farther in the blue and green narrower, because they live at greater radii where velocities ease. Absorption features from intervening gas carve thin notches into the continuum, the intergalactic medium revealing itself by subtraction, rather than by light of its own. All of it participates in a simple balance. Gravity brings matter inward friction, and fields dissipate energy as heat and light photons leave with wavelengths that bear both the imprint of the local engine and the stretch of the universe between engine and eye. The chain that led to this spectrum is still visible through the page, the lunar occultation, that fixed a position precise enough for an optical slit to be placed without waste, the radio maps that framed a core and an axis, the catalogue line that gathered a source into a name that could be scheduled on a telescope. There is no drama in the retelling, only gratitude for how methods, when they agree, become more than their separate parts. Only took the moon to tell where to look, only took a grating to tell how far, only takes a quiet acceptance of both to let the mind picture a massive elliptical host standing behind the glare with a jet that cuts a narrow lane outward and lobes that speak in radio long after optical eyes have left the dome. A gentle analogy settles at the end of the bench. The spectrum reads like a barcode, yet not one issued by the object alone. Part of the pattern belongs to the nucleus, the broad lines, the disk's slope. The dust's afterglow and part belongs to the universe, the slippage of every feature by the same factor. The scanner is the telescope, the register is the night. The tally is a distance expressed not in kilometres, but in the patient ratios of wavelength to rest. Wavelength time of flight to age of structures, power to size. Later, very precise numbers will be attached to the redshift, to the luminosity distance, to the black hole mass, inferred from reverberation to the inclination of the jet, suggested by apparent motions in very long baseline maps. In this slow exposure, the numbers do not crowd the page. The essential pattern is sufficient lines where they should be, if the cosmos expands widths, where they should be if gas orbits near a deep well, a continuum that bends where a hot disk should give way to components less hot and more extended. The quasar does not change because a human sees this. It simply keeps sending a mixed choir of photons that, when sorted by their tones, recite the same poem each time. Down in the dome air smells faintly of dust and cold metal. A red light keeps its place by the console. Someone closes the shutter and writes the time. The plate box or the digitized frame receives another file. No celebration is needed. The sky outside has not changed the point in. Virgo is still a point, still refusing to grow in the eyepiece, still granting distance without offering shape. But a coordinate in thought has shifted. The bright object that looked like a star now has the address of a distant galaxy's centre. Its light is not local. Its energy cannot be supplied by ordinary stars. Its jets, to be as long as they appear, must have been working, while continents on Earth traded shorelines. The line that meant distance keeps its meaning as nights turn to weeks and instruments improve. Other quasars reveal their own shifts, their own broad lines. A ladder becomes a network. The method turns from a revelation into a routine. The routine in turn purifies insight. Without forward motion, without a conclusion, the section rests on that steady transformation of feeling from suspicion to measurement, to the comfort that a simple, reproducible fact in a spectrum can place a lighthouse in its proper sea. The light that left when glaciers held other valleys now ends in a small rectangle of detector and is listed quietly under the right wavelength. The calm of the result fits the calm of the night. The jet still threads outward. The lobes still hold their energy along the host's outskirts. The moon elsewhere in its orbit will be useful again. The hydrogen lines, each with a centre and a width, keep repeating that single sufficient message: the source is far, the mass is great, and the universe between here and there is stretched enough to show it. Around the hidden mass, matter does not fall as a stone would. It gathers, spreads, and warms until light lifts from it in sheets. The accepted fact is steady and sufficient an accretion disk forms, because in falling gas keeps its angular momentum, and by trading a small fraction of that momentum outward through viscous and magnetic stresses, it slides inward and releases gravitational energy with an efficiency that outpaces ordinary stellar fusion. The disk is thin in the simplest treatment, a stratified, nearly Keplerian structure whose temperature rises inward so that the spectrum becomes a broad blue bump in the ultraviolet, a quiet blaze that explains why a quasar like 3C273 reddens toward the infrared and shines hard toward shorter wavelengths. Above the disk rests a tenuous hot corona, a bath of energetic electrons that intercepts part of the disk's softer light and scatters it up by inverse Compton processes into X-rays. Reflection adds its own small grammar when coronal photons strike the disk, some scatter back imprinting a Compton hump at tens of kilo electron volts, and leaving fluorescence lines iron among them that are broadened by speed and gravity. The engine does not show itself. It simply obeys. The lesser-known detail in this calm assembly concerns the way the disk adjusts where radiation competes with gas pressure. In the inner zones of a luminous quasar, radiation pressure can dominate. There, the vertical balance, the thickness and the stability of the disk depend on how turbulence generated by magnetorotational instability transports angular momentum. What emerges from calculations is both robust and modest. Despite uncertainties in microphysics, the disk can remain orderly enough to deliver matter inward for long spans, while small inhomogeneities, temperature ripples, clumpy patches can ride on top of the order and perhaps seed the gentle variability seen on days to months. If the ultraviolet brightens first and the optical follows with a lag, the delays read like a slow echo in a layered sheet of gas, each radius responding to heating from within and above, with the timing set by light and by diffusion. The section turns without hurry to the way energy transforms. Gravitational potential deepens toward the event horizon. The difference between two orbits becomes heat when friction and magnetic reconnection break the perfect conservation of circular motion. Photons carry that heat outward. Protons surrender it reluctantly. Electrons distribute it faster. The corona's existence implies a way to keep electrons hot in a region fed by cooler disk photons. Waves and reconnection events likely help. Fields tangled and then tidied by shear can accelerate particles into the tail that Comptonizes the seed light. Where the corona tapers or thickens, the spectral slope of the X-rays follows a quiet register that tells of temperature and optical depth without any need for a picture. Ironies collect gentle and inoffensive. Only took a small coefficient and alpha in a viscosity law to stand in for a cascade of turbulence that laboratories cannot fit on a bench. Only took a microscopic exchange of angular momentum between neighbours to power a beacon that outshines the combined stars of a massive elliptical, only took the inability of gas to fall straight in to make a luminous structure that never shows its texture to a telescope's direct gaze. The disk remains a topic of slowly tightening knots. Standard thin disk models capture the overall distribution of temperature and power with comforting economy, yet no one pretends that a single perfect slab suffices. At high accretion rates, advection can carry heat inward faster than radiation can remove it, swelling the inner flow into a thicker, slower cooling zone. At lower rates, the gas may decouple from radiation enough to form a hot, radiatively inefficient flow that dims the ultraviolet and hardens the X-rays. Quasars such as 3C273 live for long stretches in the bright efficient regime, but their spectra and timing keep a low voice that says the regime is not a single point. Soft excesses below a few kilo-electron volts invite layered coronas or warm Comptonization. High-energy cutoffs suggest electron temperatures not fixed but shifting with the accretion state. The mystery here is not dramatic. It is a patient workman-like knottiness. How exactly does the disk hand its energy to the corona, and how does that marriage evolve without tearing the thin structure apart? The script returns to measures that do not rely on pictures. The Eddington limit offers a balancing metaphor that is a calculation first, and an image second. Radiation pushes outward on electrons, as gravity pulls protons and electrons inward together, and the equality picks out a luminosity for a given mass beyond which steady spherical inflow would halt. A quasar does not accrete spherically, and structure gives it ways to share the load. Still, the balance sets scales. If the luminosity rests at a comfortable fraction of the limit, the implied mass of the black hole rises into hundreds of millions of suns. Independent ways from reverberation mapping take similar values by watching broad line lags change when the ultraviolet continuum breathes. The convergence is a relief without noise. It means that very different yardsticks, timing and brightness dynamics and diffusion agree on what sits at the centre. In the same quiet room, a polarimeter would find that optical polarization stays low along the direct line of sight to the nucleus, a hint that the view to 3C273 is relatively face-on through modest obscuration, that the bluest light we see is largely thermal disk emission rather than strongly scattered glow. Meanwhile, a small straight thread of optical jet light runs a few arcseconds from the core, a real rivulet of synchrotron emission that simply does not belong to the disk and corona story and yet lives in the same frame, a reminder that the engine's outputs share space without sharing mechanisms. A modern analogy is permitted at the softest volume the disk breathes like a very slow lung with inward drift, as the quiet inhale of mass and outward radiation, as the exhale of energy, the cadence measured not in seconds, but in orbits whose durations shorten toward the brink. The brink itself, the last stable circular path, stays unlit. General relativity provides the radius and the binding energy with an elegance that does not need spectacle. The spin of the black hole shifts those numbers, and so shifts the maximum efficiency of the disk's radiative work. If the hole turns with the disk, the inner edge moves inward. If it turns against the edge, sits farther out. Observers hear about spin not by seeing a silhouette, but by listening to line profiles from reflection and to the overall energy budget. Numbers trail in the literature. The present page allows only the principle that the rotational state of the central mass modulates how much light a unit of mass can become before crossing a one-way surface. The ironies can be counted again because they ask so little. Only took a deep well to make the brightest thing in a galaxy. Only took a delay of hours between band passes for astronomers to use time as a ruler when space refuses to be drawn. Only takes a whisper of extra ultraviolet to make a change in the broad lines. Days later, a vast system behaving like a patient instrument with a long response curve. Time in the engine room reads differently from time in the galaxy's outskirts. Near the hole, a day can span many orbits for gas at thousands of Schwarzschild radii. Near the lobes, a million years is only the beginning of the story. The disk ties the scales. Its variability stitches the short to the long because the stream it delivers to the jet sets the food supply for structures that will age across kiloparsecs. If the inner supply thins, the jet will not notice at once. If the inner region brightens, the distant lobes will adjust in slow motion. The two clocks keep each other honest, without ever striking together. The corona, for all its theoretical ambiguity, stays loyal to its observational duties. It provides the hard tail that brands the spectrum of an active nucleus. It seeds the reflection features that let astronomers weigh breadths against gravity. It teaches by its slope and cutoff how hot electrons can stay when bathed in soft light. A warm component below the hard tail may share the sky, providing the soft excess. Whether this is a layer above the disk or a different population entirely, the detail remains a small version of the greater patience the field maintains. Enough is known to place the parts. Enough is unknown to keep the edges soft. Down below the dome or on a mountain top where frost forms in the pre-dawn, the instruments that feed this understanding keep their own habits. Ultraviolet spectrographs require space to avoid the atmosphere's appetite. X-ray detectors count sparse high-energy arrivals and must endure background particles. Optical photometers sit in queues to trace light curves that look like low hills on long stretches of paper. Only took a network of telescopes across wavelengths to sum to a single coherent engine. Only took the agreement between bands to convince the community that no exotic power source need be invoked beyond gravity and the behaviour of ionized gas in fields. In the host galaxy, stars orbit without noticing that their central neighbour turns gas into radiation with such vigour. In the intergalactic medium, photons that began in the disk pass through filaments and halos without preference, giving up energy only to the universal stretch. The falling storm remains silent to the senses. It flickers in data, not in sound. The section holds to its slow end. There is no picture of the disk offered here because a picture is not what resolved the question. Instead, there are constraints, time delays, spectral breaks line shapes that interlock and leave a structure as inevitable as it is unseen. The light that mounts toward the ultraviolet belongs to a layered orbiting sheet of gas that surrenders energy ring by ring. The light that hardens into X-rays belongs to electrons made hot in a thin, high place. The features iron leaves behind in reflection belong to the same gravity that curves paths and slows clocks near the event horizon. The system stands complete in outline and modest in detail like a machine sketch, whose tolerances will be refined as instruments age into sharpness. The quasar shines on. Matter still finds the centre by spirals. Heat still departs as photons. The falling storm continues, patient and exact, a process that began long before any listener, and that will end on a timescale not worth measuring in human terms. The night outside, the thought is uncomplicated. Somewhere ocean air drifts across a coast. Somewhere frost thickens on grass. Somewhere the constellation Virgo rotates, carrying a point that does not dim as the Earth turns. The engine remains hidden and entirely legible. From the compact engine, a line is drawn narrow and persistent, a pencil stroke across the galaxy's dim outskirts, that keeps its aim over distances where most structures lose their shape. The accepted fact is steady and sufficient. 3C273 launches a relativistic jet, and along this jet, bright knots appear to move faster than light because of geometry and timing, a superluminal illusion that obeys relativity and reveals a flow travelling close to light speed at a small angle to the line of sight. The jet announces itself across bands. In radio maps it runs clean and long with a spine and small brightenings that the literature names as components. In X-rays it glows where high-energy electrons and strong fields collaborate. And in the optical, a short, elegant segment lies a few arc-seconds from the core. A sliver that proves synchrotron processes can carry electrons to energies high enough that even visible light is part of the jet's quiet speech. Polarization vectors in those optical knots line up along ordered directions, and the electric vectors twist gently, where shocks or bends suggest a change in field. The picture that emerges is not a picture at all, but a collection of constraints arranged like a calm scaffold. Apparent superluminal motion follows from simple steps. A disturbance travels down the jet with a velocity just under light speed. Because the jet aims almost toward the observer light from a later position, has less extra distance to cover than light from an earlier position, so the time between two arrivals contracts. Divide the apparent separation on the sky by this shortened interval, and the speed in appearance exceeds the universal limit while the true speed remains lawful. The knots move, the map epochs line up, the separation grows in small annual increments that VLBI arrays can measure with their Earth-wide baselines and discipline clocks. Only took projection to make a lawful flow look lawless. Only took a near alignment to turn months into a record of faster-than-light motion that never breaks any rule. Only took a series of careful overlays to convert a string of noisy images into a gentle calculation of angle and true speed. A lesser-known detail lives in the brightness temperature puzzle. If the core's compactness and flux were taken at face value, without considering motion and beaming, the brightness temperature would exceed limits set by inverse, Compton cooling, threatening to flood the source with self-made high-energy photons that would sap the radio light away. Doppler boosting and time compression repair this contradiction. A flow pointed near the line of sight concentrates emission into a forward cone and reduces the time available for electrons to cool in the observer's frame. The fix is modest and sufficient, and in 3C273, as in many jets, the required beaming sits in a reasonable range set by the same apparent motions that VLBI traces. A small persistent uncertainty remains at the jet's heart, invited to stay without frustration. Exactly how the flow stays so narrow for so long is known in principle magnetic fields guide and Coulomb external pressure shapes and cushions, but the way internal magnetization shear layers and entrainment collaborate to keep the beam together across parsecs and then relax it into plumes. Over kiloparsecs is a long arithmetic of balances that simulations still refine. Particle content holds another gentle question. Does the jet carry mostly electrons and positrons, or a heavier mixture with protons that shoulder most of the momentum? Polarization spectra and dynamics offer partial hints. None settle the mass ledger completely. Likewise, the prime sites of acceleration standing, shocks, recollimation zones, or bouts of magnetic reconnection that tear and retie field lines into plasmoids share the work in different measures along the way. The flow keeps its content private behind the evidence it cannot help but leave. The section lingers over how time turns into a ruler when space refuses to resolve. VLBI snapshots a milliarc-second structure, and then returns months or years later to watch it change. The distance and knot travels measured in microarc seconds can correspond to light years within the host. A straight line traced across several epochs yields a vector. The slope of that line becomes the apparent speed. The intercepts, full of clock corrections and phase solutions, become safeguards rather than distractions. Only took the Earth's rotation and a ring of antennas to draw a beam finer than any single dish. Only took a disciplined return to the same field season after season to make a movie from still frames. Only took a low-contrast persistent structure to let the eye believe in the continuity of a flow that the instruments merely sample. In the optical, the few-arc-second jet keeps its own slow breathing. Its surface brightness does not shout. It whispers change over years. Polarization angles drift in small increments as if the field were turning a wrist. Shocked regions brighten a little, and then yield to quieter stretches. The optical segment sits so near the nucleus in angle, and so far in true distance that the two clocks engine fast and lobe slow meet in the middle. Photons from the ultraviolet face of the accretion disk begin their travel in the same hour that electrons in a jet knot step up an energy decade. Yet the knot's aging will be read in spectral slopes years later, while the disk's flicker will be over by morning. The jet writes time into space so that a patient observer can read both with one gaze. The physics of emission stays modest and sure. Synchrotron radiation accounts for radio through optical light, along most of the jet with spectra that steepen where electrons have aged in the field and flatten where fresh acceleration has worked. In X-rays, two options share the frame very high-energy synchrotron from a tail of electrons that the jet somehow keeps replenishing, or inverse Compton scattering where electrons boost ambient photons, often the cosmic microwave background into the Kev range, when the flow still carries relativistic bulk speed on large scales. In 3C273, the balance between these options shifts along the length and between models, and the literature leaves room for both. The uncertainty is not a flaw. It is a measure of how closely theory is pressed to explain small differences in slope and in brightness across a structure so thin on the sky that a single pixel can mix regions with different conditions. The jet also explains itself with its quiet failures. It bends slightly. It brightens where a bend or a compression throws more emissivity into the line of sight. It fades where the field relaxes and the particle distribution coasts. There is no need for soundtrack or metaphor, yet one gentle analogy is allowed. The beam behaves like a river confined by its banks fast in the centre, sheared at the edges with eddies that spin off and then disappear downstream, all of it tilted so that the reach seems shorter and the water seems quicker than it would from above. The bank in this case is a sheath of slower plasma and the surrounding medium. The eddies are the knots. The tilt is the small angle to the observer. The ironies gather again because they are light and do no harm. Only took a tiny misalignment from straight at us to turn an ordinary near-light speed into an extraordinary apparent one. Only took turbulence's tendency to disrupt flows to teach why this one's steadiness is remarkable. Only took the immense scale of a kiloparsec to make changes visible on the scale of a human graduate career, so that something larger than star clusters can seem quick if it is pointed our way. The jet communicates with the nucleus by the simplest channel possible supply. If the inner disk changes its rate of feeding, the jet's base will respond on engine timescales. The far knots will accept the news late transformed by adiabatic expansion and radiative loss. This delay writes causality into the map flux changes march outward at the flow speed, and any alignment of brightenings along the jet that shares a single epoch at the core announces a coordinated episode at launch. Very often the data cannot follow the whole chain. Weather break sequences, instruments change, funding shifts. Yet enough cases remain whole that the inference keeps its quiet weight. The base's mood and the beam's replies share timing. In the host galaxy, the jet is narrow intrusion that most stars can ignore. It threads halos of hot gas and leaves cavities and filaments where it displaces and compresses. The displaced gas cools, wavers and remembers. Polarization maps show where fields have been drawn like taffy. Faraday rotation tracks magnetize plasma along sight lines that the jet has organized. Far out the beam slows and widens into plumes, and the radio lobes that surveys first catalogue take over the story. Energy that began in a disk only a few light hours across has now been sorted across hundreds of thousands of light years. The jet is the courier that makes both scales part of one ledger. Down on Earth, the instruments keep their rituals. Correlators churn through baselines. Phase solutions hop from calibrators to targets. Imaging algorithms coax a clean beam out of imperfect coverage. Observers choose reference features that survive from epoch to epoch and assign them as origins so that proper motions can be measured. Models fit straight lines, sometimes gentle arcs. The uncertainties are written honestly with bars and shaded regions. Only took a tolerance table and a calibration log to domesticate a structure that does not know it is being measured. Only took patience for the errors to shrink to the point where 1/10 of a millisecond is a meaningful stride. Only took a community's agreement on conventions to let one decade's data talk to the next. The section holds at a quiet conclusion that is not a conclusion. The jet continues to move. New knots appear. Old ones fade. The apparent superluminal speeds remain a lesson that perspective and near-light motion can conspire to surprise without upsetting any law. The angle to the line of sight is small but not zero. The bulk speed is high but not perfect. The field is ordered but not pure. Everything is nearly something, and the nearness explains the beauty nearly in our direction, nearly at light speed, nearly steady over distances that should defeat steadiness. The core still flickers, the optical sliver still carries polarization like a flag, the radio spine still lengthens in careful drawings made from far antennas that share one night sky. The jet is aligned with time in the only sense that matters here. It turns time into distance and distance into time so gently that a human calendar can coexist with a cosmic yardstick, and the two can meet in a set of dates under a sequence of images where a small bright knot moves a small bright step and says without emphasis that the beam has not failed. Close to the centre, gravity twists space and time into a single fabric that turns as a whole, and fields thread that turning. The accepted fact stands steady. A rotating black hole can power a relativistic jet by transferring part of its spin energy to electromagnetic fields that tap the horizon, an arrangement captured in theory by the Blandford-Zanayak mechanism, and supported by simulations and the observed need for strong ordered fields near the launch point. Frame dragging, the quiet compulsion of space-time to co-rotate, sweeps magnetic field lines anchored in plasma just outside the horizon. Currents close through that plasma and out along the jet, and the system, without moving any material part of the hole itself, extracts rotational energy as pointing flux that later becomes the particles and light seen far from the core. The ingredients remain spare rotation field conducting plasma. The engine does not show a gear or a shaft. It shows a direction and a power. A lesser-known detail arrives in the discipline of accretion, where fields grow strong enough to push back. When the inflow drags magnetic flux inward, faster than turbulence can let it slip outward, flux piles near the inner disk and the system enters a magnetically arrested state. Their magnetic pressure throttles the inflow intermittently, and the jet leaves with higher magnetization and stronger collimation. The literature names this a mad regime, and simulations in general relativity show the flow stuttering and surging around an inner magnetized barrier, yet maintaining the long average that a quasar requires. Variability at the base, small but decisive, follows from this arrest and release, an interior punctuation that observers glimpse as gentle changes in core polarization angle, or as coordinated brightenings across bands when the throat clears and fields reconnect. The script stays in present tense and keeps to the quiet arithmetic of power. Rotational energy of a black hole with high spin can exceed the mass energy of many suns. The horizon's angular frequency multiplies with the field strength and the area threaded by field lines to set a jet power. The disk's own contribution via magnetocentrifugal launching, where field lines anchored in the rotating plasma fling material outward, adds its voice. Both channels can coexist, a spine dominated by electromagnetic extraction from the hole and a sheath fed by the inner disk. Polarization patterns that place ordered vectors along the jet's axis high, Faraday rotation near the core, and the persistence of narrow collimation are all consistent with a launch zone that is at least at first more field than matter, only took the absence of a solid surface to make a better flywheel than any star can offer, only took a field line intangible and exact to carry torque out of a place that swallows everything else, only took the rotation of space-time itself to become a power plant that leaves no moving part to wear out. The uncertainty that remains is not a failure, but a boundary. Exactly how much of a given jet's power comes from black hole spin versus disk rotation is measured indirectly and modelled dependently. Spin can be inferred from the inner edge of the reflection spectrum or from overall radiative efficiency. Magnetic flux supply depends on how the galaxy feeds the disk. Alignments can evolve as inflow carries angular momentum at angles to the hole's own axis. The jet's brightness and motion constrain combinations of these, not each alone. The multiplicity of workable arrangements hole-dominated spines, disk-fed sheaths. Mad and non-mad episodes leaves a soft fog that observation gradually thins but does not clear completely. Another quiet uncertainty persists in composition. Electromagnetic extraction gives pointing flux first. The conversion to an electron-positron pair plasma or to an electron-proton mix involves dissipation shocks or reconnection, whose details depend on magnetization and shear. Both options remain open along different reaches, and both can fit spectra with small changes in slope and cutoff. The section lingers where fields and rotation speak a common language. In the ergosphere, a region outside the horizon where no static world line exists, frame-dragging forces any matter to co-rotate. The Penrose idea that energy can be mined from rotational motion takes an electromagnetic form. Here field lines thread the ergospheric plasma. Induced electric fields set currents. Pointing flux flows outward. No turbine blades spin. The work is bookkeeping angular momentum moved across a surface energy. Carried in a field, the whole spin reduced infinitesimally, as the jet's asymptotic power increases by the same book value. If the inflow keeps spin high, and the disk delivers fresh flux, the ledger stays balanced, and the beam continues. A gentle analogy can sit here without strain. The horizon and its threaded field behave like a smooth, invisible dynamo, not with coils and iron, but with geometry and magnetism, and the voltage it develops is measured not in volts, but in the luminosity of a narrow, persistent outflow that keeps its aim across scales that dwarf a galaxy's stars. The ironies gather softly again. Only took a hole that lets nothing escape to send out one of the most coherent messages in the sky. Only took turbulence in a disk to supply the ordered field that steadies a jet. Only took the random hierarchical feeding of a galaxy's gas to build a machine whose output is the straightest line that galaxy draws. The field's organization near the base leaves fingerprints. Polarization rises in compact cores at millimeter wavelengths, where Faraday depolarization eases. Rotation measures grow large where magnetized plasma thickens. Sudden swings in the electric vector position angle can signal the passage of a disturbance that rotates the field, or the crossing of a standing shock that aligns it. In 3C 273, as in its peers, these changes travel with the superluminal components tracked by VLBI, and occasionally a brightening in gamma rays coincides with a millimeter flare and a new knot's departure, a timetable that fits reconnection, or shocks at the collimation zone where pointing flux must become particle energy to radiate so quickly. The timetable is a map in one dimension. Time replaces distance, and correlations stand in for an image the instruments cannot yet give. The engine's moderation matters. Too little flux, and the jet weakens and flares only near the base. Too much, and the arrested state chokes the disk into pauses that push variability above the gently flickering level observed. The system self-regulates through interchange instabilities and reconnection field bundles trade places. Loops break and rejoin. Magnetic islands form and release. The result is a staircase that looks like a slope when viewed from far away, a run of small steps that maintain a long, steady average. In the flow itself, the spine may remain magnetically dominated across parsecs, converting pointing flux gradually to kinetic energy. Farther out, shocks at bends, encounters with a slower sheath or shear-driven turbulence, move energy into electrons and sometimes into protons that may contribute subtly by hadronic channels. The script does not need to decide. It only notes that both families of models leptonic and hadronic survive demanding fits with multi-band light curves setting the limits. The accretion state sets the tone. When the disk's ultraviolet grows line-emitting clouds brighten later, and sometimes the jet's base responds as if a deeper feed reached the magnetized throat. But the coupling is not one-to-one. The jet can maintain a mood of its own, because its power taps spin as well as inflow. This independence puts a quiet ceiling on expectations. Changes at the centre do not always march outward in a single file. Some are damped in the arrest and release near the horizon. Some are amplified by local reconnection that cares more about magnetization than about feeding rate. Only took a parameter that cannot be seen spin to explain why two nuclei with similar disks can launch very different beams. Only took a reservoir that cannot be depleted quickly for a jet to stay bright while the disk only nods. only takes a change in field polarity in the incoming gas to rearrange the entire inner architecture for a while. The geometry remains a teacher. If the spin axis of the hole is not aligned with the angular momentum of the outer inflow, general relativistic torques twist the inner disk into a warped alignment near the hole, a Bardeen-Peterson settling that lets the jet point with the hole even if the outer galaxy disagrees. Over long times the axis may precess or wander, the jet may gently curve, knots may trace slow arcs on VLBI motions. The host galaxy's starlight, when finally extracted from beneath the glare, tells a compatible story, a massive elliptical with a large halo of hot gas, a quiet environment that gives a collimated beam room to stay narrow before it finds the boundary, where it must share momentum with the surroundings. In this arrangement, the jet is not only a courier, but also a regulator. By carrying away angular momentum and energy, it helps the inner disk keep accreting steadily. By stirring the circumgalactic medium far away, it leaves cavities and filaments that adjust how gas can fall back later. Feedback becomes an unhurried loop across timescales engine to halo to feeding streams to engine, a cycle that leaves no drama in any single moment, but writes structure into cluster maps over millions of years. The method by which the field first arrives at the centre stays gently mysterious. Large-scale flux can be dragged inward by cold streams, or built up by dynamos in the turbulent disk, or delivered episodically by magnetised clouds. In each case, the balance between advection and diffusion decides whether the inner region becomes magnetically arrested, or remains in a less choked, still-threaded state. Observers listen for clues, long plateaus in jet power, abrupt changes in polarisation, shifts in core brightness temperature. None alone proves provenance. Together they mark regimes rather than events, and the regimes agree with the pictures sketched by simulation. Down on Earth, the inference chain holds. No instrument sees frame dragging at the horizon directly, yet the match between required field order, implied spin from spectral fits, and the power budget of a long persistent jet makes the spin extraction model live comfortably among alternatives. The community keeps its language dry because dryness protects against wishful closure. Papers say consistent with suggests permits, and the beam keeps moving while words keep pace. The section rests with a view that does not ask for an illustration. Near the centre, a rotating space-time hands energy to a field. The field hands energy to a flow. The flow hands energy to particles that spend it as light along a line that begins inside a few gravitational radii and ends in lobes that touch the outskirts of a galaxy. The whole slows by an amount that only the ledger can see. The disk continues to feed, the flux continues to arrive and to be arranged by pressure and geometry. The jet owes part of its life to a spin that the universe granted when gas and stars long ago fell in with a shared sense of rotation, and to the discipline of fields that hold shape in a place where everything else forgets its own. The lighthouse in Virgo shines on not by burning but by arranging motion into order, and order into light with no moving parts displayed and no sound. Outside, night air stands still over rooftops. Frost grows in shadows. The bright point remains indistinguishable from a star to any unassisted eye. Inside the equations, a power plant turns indifferent to being seen exact in its exchange. Beneath the bright nucleus, a galaxy waits with the patience of stone, its starlight smoothed by age until the profile swells like a low hill that keeps rising as the eye walks outward. The accepted fact sits in the middle of the quiet 3C273 lives in a luminous elliptical host, and when the nucleus is modelled and subtracted, a spheroidal galaxy emerges with a broad, smooth light profile, and a reach measured in tens of kiloparsecs, the kind of environment that often companions powerful radio jets. The way this host comes forward is a craft and not a single exposure. Observers build a point spread function, the telescope's signature of how a point of light spreads, then fit the sharp core with that signature, peel it away, and let the residual grow into an image that would otherwise be drowned. On early plates, the subtraction is an art of retouching and profiles. With space-based optics and adaptive mirrors, it becomes a delicate arithmetic of pixels. Either way, the result is the same. Under the glare sits a large old galaxy, whose stars have long since left their birth gas and settled into the slow orbits that give ellipticals their calm. A lesser-known detail rests quietly at the galaxy's edge. After deep exposures and careful modelling, fainter symmetries and low-contrast shells sometimes appear, the whisper of past interactions that stirred the outer halo and left ripples that need millions of years to relax. The signs are not garish. No bright torn spirals, no dramatic bridges, only a change of slope. Here a lopsided contour, there as if the galaxy remembers a minor visitor, or a long-ago merger under layers of subsequent stillness. These traces, when they're found, sit well with a nuclear history that demands fuel. Small companions and stellar mass loss feed the centre in slow, persistent ways that do not require a recent catastrophe. The soft ironies that accompany this unveiling assemble without effort. Only took removing light to see more light the host appears when the brightest part is taken away. Only took the largest thing in the frame to hide in plain sight, while the smallest, the nucleus, declares itself across the spectrum. Only took a galaxy with hundreds of billions of stars to be overshadowed by a region no bigger than a solar system. The scale reversals are routine enough in quasars to feel like a kind of celestial joke told very softly. The section lingers on the host's shape because shape carries history. A de Vaucouleurs or Circic profile fits the starlight, and the best fits favour values that swell more steeply than disks as they should for an elliptical. Isophote's contours of equal brightness remain nearly round, perhaps with a gentle twist, with radius that hints at triaxiality. If dust is present, it is not a grand crossing lane, but a faint patch or loose filament that skims the nucleus and reddens local light by a small amount. Star-forming knots are rare. Most of the blue in the core is nuclear, not stellar. Colours move to the red away from the centre, a quiet old population with metallicities built by generations of stars that formed quicker and earlier than disks tend to do. Kinematics, when measured, tell a compatible story. Velocity dispersions, high rotation, modest the line widths that one expects from stars orbiting in the smooth potential of a massive spheroid. The central black hole mass inferred from reverberation mapping, and line width sits in the range that agrees with the galaxy's dispersion if one adopts the measured correlations. The rough harmony between a nucleus weighed by timing and a host weighed by starlight has become one of the modest satisfactions of this field. The optical jet seen a few arc-seconds from the core passes across this starlight, like a thin filament laid on velvet. Its knots add a tracery of blue to an otherwise even field. Polarization maps, if drawn, would show the jet's ordered vectors threaded through a background with little polarization, the signature of a synchrotron line crossing a sea of ancient stars. The jet does not disturb most of the host. The host does not extinguish the jet. They share a frame without contest. A gentle analogy offers itself without strain. The subtraction that reveals the host is like lifting a bright coin from a sheet of paper and noticing the paper's texture. At last, the weave that was always there but could not be read while metal flashed in the light. The uncertainties are small and invited. Even with good subtraction, light very near the core is hard to assign nuclear scattered light compact star clusters, and the innermost stellar profiles share a few arc-seconds where the point spread functions wings and the instrument's breathing leave residue. Numbers there come with bars and brackets, the total mass-to-light ratio of the host, while bounded by population models and dynamics, still admits a family of solutions that trade stellar age metallicity and dark matter fraction. The precise path that built the elliptical, whether a few large mergers early or many small ones strung across time, remains a narrative inferred from faint features rather than a recorded sequence. None of this uncertainty troubles the main picture. It only keeps the edges soft where they should be. The environment around the host registers in faint extended gas and in the behaviour of the radio lobes. X-ray maps of hot atmospheres around massive ellipticals show that the circumgalactic medium here can cushion a jet, allowing it to keep its collimation longer and to deposit energy into cavities at large radii. The radio lobes, long-lived and patient, excavate and sculpt this medium, and the medium in turn feeds or starves the centre by how it cools and falls. Feedback here is not an explosion, but a slow exchange that ekes out consequences over tens of millions of years. Only took a steady jet to hollow a region that later resists gas from condensing. Only took that resistance to moderate the fuel supply the nucleus might have had. Only takes such moderation to keep star formation low and the elliptical's colours old. The inner structure of the host, whether it keeps a shallow cusp of starlight or flattens into a small core after scouring by a binary black hole, connects to a different clock, one that measures the galaxy's own merger past. High-resolution profiles sometimes favour a mild core, as if inward scattered stars have been removed by the hardening of a past binary at the centre. If present, the core is not a spectacle. It is a few parsecs of gentler slope written into a profile that otherwise behaves like a textbook. The nucleus now adds its own layer of difficulty by flooding that region with light that must be removed, so the measure comes with care and with acknowledgement of the lingering ambiguity. The host's halo extends farther than photographs suggest at first glance. Deep stacks and careful sky subtraction bring up a faint aureole stars in long, slow orbits, whose apocenters skirt the galaxy's nominal edge and feel the beginning of the group or cluster potential. Here the third soft observation settles only took the faintest part of the galaxy to be the longest record of its rearrangements. The outskirts keep the time of tides, while the core keeps the time of the engine. Globular cluster systems, when counted, lean toward richness in such hosts. Their colours split into old metal-poor and somewhat younger metal-rich families, a fossil of the two tracks early collapse and later assembly that many massive ellipticals follow. The nucleus has little to do with these clusters now. They move like old citizens in a town whose centre has grown loud, but whose neighbourhoods keep their habits. Spectra of the host's light average many histories. Absorption lines from magnesium and iron rest where they should for an aged population. Balmer absorption is weak as expected when young stars are scarce. Deviations from these expectations when they appear are local and small, often near the jet, where shocks may have compressed gas long enough to form a few new stars that do not dominate the whole. Integral field spectrographs can map these subtleties, laying velocity fields over line strengths, and in such maps, 3C273's host does not surprise. It is stable, heavy, and slow to change. If the quasar turns down, the host remains. If the quasar brightens, the host remains. The two registers, the fast and the slow, share the same page without ever moving to the same tempo. The night's dryness suits the arithmetic. Luminosities are quoted in familiar solar units. Half-light radii are given in kiloparsecs. Cirsic indices and dispersions enter tables, and then leave to be used in other papers where correlations compile. Only took a handful of parameters to describe a galaxy sufficiently for many purposes. Only took those parameters to agree with the black hole mass for the entire system to feel internally consistent without anyone demanding a picture more complete than the data can support. Astronomers are careful not to promise more the subtraction cannot invent detail. The host revealed this way is what stands after the model, and the instrument's fingerprint are removed. Yet for the purposes of understanding where a bright quasar lives, this is enough. It lives in an old, large, round-leaning galaxy with little cold gas in a halo that holds hot plasma in a neighbourhood that does not batter it daily. The arrangement gives the jet room, gives the disk fuel that arrives not as a flood but as a steady seep, and gives the nucleus a stage on which a point of light can dominate the face of a city without rearranging its streets. The section slows further and lets the image settle a broad, even field of red starlight. A white point at the centre that subtraction temporarily hides. A thin, inclined filament of optical jet like a hair caught by chance across the lens. Outer isophotes that loosen and turn faint at the corner of the frame. The day-to-day cares of subtraction calibration and sky flats recede, leaving the impression of weight and age under brightness. The host behind the glare is not a surprise to theory. It is a confirmation that the strongest engines prefer the largest foundations. The galaxy is not a character in a story. It is a context that explains why the lighthouse can stand for so long and shine so far. When the model's point spread function is put back, the nucleus returns, and at once the eye forgets the hill and sees only the bright coin again. This forgetfulness is practical. Most instruments saturate on the core before the outskirts come up. The three ironies stay where they were. Everything large hides under something small. Everything old hides under something young. Everything quiet hides under something loud. The telescope dome breathes. Someone turns a wheel that brings the shutter inward. Frames are written to a disk where they will later be aligned and stacked. Outside the constellation, Virgo carries the point westward, and the city beneath the ridge of the hill still does not show on the eyepiece until the coin is lifted. The host remains under all of it, waiting without any need to be seen, a steady foundation for a transient brightness that to human senses looks like permanence. Brightness does not hold perfectly still. It rises by a little, falls by a little. And in those small changes a ruler appears where a camera cannot draw a line. The accepted fact that carries this section is plane, and sufficient quasar variability, measured across days to months, and then followed by slower echoes in emission lines, turns time into distance through reverberation mapping, allowing astronomers to infer the size of the broadline region and to weigh the central black hole without ever resolving the nucleus on the sky. The method is a patient exchange between light and gas. First, the ultraviolet optical continuum from the accretion disk flickers, more a slow breathing than a strobe because the inflow is not perfectly smooth, and the disk and corona share energy in fits and starts. Later, the broad hydrogen and other permitted lines brighten or fade in response, delayed by the light travel time from the source of the continuum to the clouds that reprocess it. Measure the lag between the original flicker and the echo in the lines, multiply by the speed of light, and a radius emerges. Combine that radius with a velocity inferred from the line width, and gravity's quiet equation gives a mass the larger. The line width for a given radius, the heavier the central object must be. The technique is not romantic. It is bookkeeping with photons and clocks, and it works. A lesser-known detail sits at the edge of this practice, where careful monitoring becomes craft. The drive to follow 3C273 and sources like it through all seasons links small telescopes and large amateurs, and professionals' photometry and spectroscopy in rings that circle the year. Nightly points taken under suburban skies add weight to campaigns on big mirrors and spaceborne ultraviolet eyes. Gaps that weather would carve are filled by sites far apart in longitude. Flat-fielded CCD frames from a backyard feed the same structure function as high-precision space data. The chain has no weak link if the cadence is kept in reverberation. Mapping steadiness of attention is more powerful than a single perfect night. Only took a light curve that looks like a slow hillside to weigh a darkness that outmasses hundreds of millions of suns. Only took hours of modest observing to measure a distance that no interferometer can yet draw in the nucleus. Only took the disk's untidy breath to make the broad lines ring like a bell a few weeks or months later, giving away their radius by the delay in their reply. The section lingers on how the flicker itself constrains size even before the echo is read. A region cannot vary faster than light can cross it. Thus, a day-scale change marks a compact source, and a month-scale swing points to a larger zone. In 3C273, the continuum's low-amplitude undulations on timescales of days to weeks place the emitting annuli in the inner disk and corona at dimensions counted in light days, while the broader, slower adjustments in the lines locate the reprocessing clouds tens to hundreds of light days away. The numbers need not be written. The relation suffices. Short times mean near, longer times mean far. The silent arithmetic of causality becomes a ruler that admits no exceptions. The variability is not white noise. It is read with more power on long time scales than on short, a statement that the engine's memory is not instantly erased. Structure functions rise with lag. Power spectra tilt. Breaks appear where one regime of fluctuation yields to another. In optical bands, the disk's outer layers answer more slowly than the ultraviolet inner rings, and the light curves in neighbouring bands shift by hours to days, with bluer bands leading and redder bands trailing as heat diffuses and reprocessing adds its own gentle delays. Cross-correlation functions capture these offsets without insisting on a model. The peak of the correlation stands where the echoes align, and there the ruler is read again. A quiet uncertainty is invited to remain where it belongs, the exact geometry and kinematics of the broadline region. Is it a thick disk of clouds lit from above, a wind lifted from the inner disk and accelerated outward a more spheroidal mist with coherent streams? Do the clouds move predominantly in bound orbits, or is there a component that flows inward or outward? Velocity-resolved reverberation, mapping reading lags across the width of a line suggest gradients and asymmetries that change with time, a whisper, that the region is stratified and dynamic, not a persistent ring. The mass that emerges from the simple product of radius and squared velocity must then carry a scale factor that encodes geometry and inclination. The factor is calibrated by ensembles and by the broader correlation between black hole mass and host galaxy velocity dispersion. Each improvement narrows the spread without pretending to closure. The method's durable grace lies in its indifference to unresolved images. It requires clocks, not pictures. The ironies that belong here step lightly. Only took not seeing a thing to know its size, light's delay stood in for any lens. Only took the very disorder of inflow to become the signal that measures the order of gravity. Only takes patience to translate noise into a mass, a small triumph that grows more certain the longer the observer refuses to hurry. The campaign's practicalities accumulate with a calm rhythm. Reference stars anchor photometric 0 points. Slit losses in spectroscopy are tracked by ratioing to narrow lines that vary little or not at all on the campaign timescale. Air mass and seeing are written in margin so the reduction knows what to trust and by how much. Ultraviolet satellites take their turns in daylight orbits. X-ray detectors count fewer harder photons and display their own quicker temper. Radio arrays knit together detections of flares at millimetre wavelengths that sometimes coincide with changes in the core's polarization and the launch of a new VLBI component. Occasionally a rare alignment with a foreground galaxy adds micro-lensing to the mix, a tiny accidental telescope that can magnify part of the nucleus disk, more than broad lines blue, more than red, imprinting chromatic changes that reveal sizes by which components are differently affected. These episodes are rare in 3C 273, but common enough in the class to remind the field that even gravity's small tricks become teachers when the images are too fine to see. The analogy for this whole practice keeps its voice level. A player touches the lowest key on a piano, and then higher keys answer a half-second later from a nearby wall, the echo's delay giving away the room's width. In the quasar, the disk plays the note, and the broadline clouds answer, and the room is not a room but a radius in light days. The line widths are not sound but speed, and the mass is the minimum that can keep such speeds bound at that radius. The disk's faster colour changes. Blue leading red are like the first touch of sun on the highest parts of a hillside with lower slopes warming later. Nothing chases anything but timing explains position. The uncertainties do not unsettle the centre. Even when the broadline region rearranges, even when lags change with luminosity, because the ionization front wanders outward or inward. With the quasar's mood, the mass estimate stabilizes when many cycles are included. The same source observed over years reveals a breathing relation between continuum level and lag, with the radius scaling roughly like the square root of luminosity, a restful dependence that fits the picture of a region set by ionization balance, rather than by architecture alone. Only took luminous seasons and quieter seasons to watch the system tune itself. Only took that tuning to verify that the clock we read is the clock the gas keeps. The disk's own variability is quietly instructive about how heat moves. When ultraviolet leads optical by days, the delay exceeds the pure light travel time between rings, hinting at inward to outward reprocessing and diffusion that adds small finite lags. The temperature profile that thin disk theory predicts shows up not as a photograph, but as the way colours drift and then settle, and the corona's temper appears in the hardtail's slope as it hardens and softens with the soft bands. A soft X-ray excess that brightens a little out of step with the hardest X-rays speaks of a warm Comptonizing layer that is neither purely disk nor purely corona, a middle skin that shares heat between the two. None of these traits are dramatic. They are the kinds of differences that require stacked nights to notice. In that requirement lies the quiet community that the method builds many observatories, many weather systems, many calendars that ignore weekends. The AGN that looks steady to an unassisted eye that's merely a star-like point in Virgo turns out to be a clock factory under magnification in time. Every band carries a slightly different clock. Every echo synchronizes one with another. Every synchronization produces a length that would otherwise be hidden behind glare and distance. Down at the scale of a few light days, turbulent cells in the disk rise and sink. The corona stitches and unstitches, magnetic loops and reprocessing layers adjust their emissivity. Up at the scale of the broadline region, clouds or streams re-emit with delays that make a curve of line flux that looks like a softened, shifted version of the continuum. Much farther out, nothing notices for a long while. The jet's knots, being couriers of past conditions, respond on their own schedule. The radio lobes, being reservoirs, do not respond at all within human campaigns. The coexistence of these clocks is the most ordinary thing in the system, and the most useful short clocks for the engine room, medium clocks for the echoing gas, long clocks for the structures that store energy far from the core. The section rests where the arithmetic has brought it. The mass implied by the lags and width sits among values that other methods endorse. The radius implied by the same lags behaves with luminosity as photoionization arguments predict. The size of the continuum source implied by interband delays agrees with the disk that warms inward. The quiet uncertainties, geometry, inclination details of diffusion do not obscure the central outline. Only took a notebook with dates and fluxes to open the nucleus a crack. Only took cross-correlation to turn an unresolvable point into a measured distance. Only takes returning night after night to watch a brightness that looks like weather become under patient reduction, the fingerprint of gravity. Outside the observatories the season changes without comment. Leaves curl and fall somewhere. Ocean air carries salt through a harbour. Frost gathers and then yields at dawn. The constellation Virgo tips westward. The point that is 3C 273 still looks like a star through a small telescope. But on the page where times were written, the point has acquired depth, a near zone measured in hours, a surrounding region measured in weeks or months, and a mass whose authority requires no picture at all. Across wavelengths, the quasar does not change places, it changes voices. The accepted fact that holds the section steady is simple and sufficient. The spectral energy distribution of 3C 273 drawn from radio through gamma rays is a composite of thermal disk light, non-thermal jet emission, dust re-radiation in the infrared and high-energy components from Compton, upscattering with a persistent soft X-ray excess that resists reduction to a single tidy model. The spectrum is not a line, but a landscape. At long radio wavelengths, the jet and lobes speak in synchrotron tones that slope gently downward with frequency. At millimeter and submillimeter bands, the compact core rises and falls as shocks, and fresh electrons change the highest energy tail of that same synchrotron population. In the near and mid-infrared warm dust that has seen the nucleus answers with a smooth bump. In the optical and ultraviolet, a broader blue arise. The big blue bump marks thermal emission from an accretion disk with temperatures that increase inward. Soft X-rays curve upward into an excess that is too bright to be a simple extension of the disk, and too gentle to be the hard coronal tail. Above a few curvae, the Comptonized continuum takes weight, and at still higher energies into gamma rays the jet recovers the lead with inverse Compton light from electrons that boost ambient photons. The spectrum is a conversation in which no one voice is always speaking. A lesser-known detail sits in the infrared, where subtle broad features betray dust. Mineralogy, silicate emission can appear around 10 micrometers low, in contrast but discernible when the nucleus is not in a jet-bright state. The same region shows that even in a luminous quasar with an old elliptical host, circumnuclear dust grains survive to absorb and re-emit a portion of the ultraviolet folding geometry and composition into the continuum. The mid-IR slope often lies between the pure torus templates of edge-on systems and the flatter shapes of jet-dominated blazars, a quiet reminder that 3C273 is seen at a modest angle, where both nuclear dust and beamed power contribute, neither allowed to monopolise the frame. Ironies gather lightly around the plot. Only took a single smooth curve on paper to conceal half a dozen physical processes working in parallel. Only took one index AOOX, a simple measure of the optical to X-ray slope, to compress a system whose inner parts heat scatter and reprocess on different clocks. Only took subtracting the jet's flare state from one epoch to reveal that the steady disk beneath also changes on its own. So steadiness is an artifact of averaging, not a property of the engine. The soft X-ray excess keeps its gentle mystery. Warm Comptonization, where seed ultraviolet photons pass through a layer of electrons at temperatures of tens to hundreds of electron volts, reproduces the shape with appealing economy. Blurred reflection from an ionized inner disk smeared by speed and gravity can also contribute. Both mechanisms coexist comfortably in fits, yet the exact partition between them varies from epoch to epoch, and the way the excess tracks or fails to track the ultraviolet leaves room for more than one route, from seed photons to soft X-rays. The coronal hardtail speaks more cleanly as the cutoff energy shifts the implied electron temperature and optical depth shift too, telling of a plasma that cools and warms with the supply of soft seed light. Even here, moderation rules. In bright states, the corona softens and the cutoff lowers. In quieter intervals, it hardens and the cutoff rises. The disk and corona exchange energy like neighbours who borrow and return without receipts. The jet's signature climbs back up at high energies. In 3C273, the gamma-ray band does not always dominate, but when it does, the light curves harden and align with millimetre peaks, and the ejection of a new VLBI component, setting a timetable in which Compton's scattering in the moving flow, often on the jet's own synchrotron photons, synchrotron self-Compton, and sometimes on external fields supplies the high-energy rise. A dry observation cuts through the glamour, the same source that calibrates radio arrays, because it is bright and compact, must be de-beamed in thought to compare its disk to other quasars. The act of using it as a standard in one band turns it into a special case in another. The section lingers over how the pieces fit along the curve without forcing a single picture. The radio to millimetre slope polarization and variability mark optically thin and thick synchrotron regimes, with breaks where self-absorption yields and where electron aging steepens the spectrum. The near IR drop into the optical rise is the place where jet and disk trade authority. At times the jet fills the gap, at other times the big blue bump lifts past it and shows the disk's temperature profile by the curvature of the optical UV continuum. Superposed on that curve, broad emission lines sit with their own delays and ratios, not features of the continuum but markers of light that the continuum has lit. Hardwood, the coronal power law and reflection combine into a slope and a hump. Iron fluorescence broadens according to speed and gravity close to the hole, writing radii and inclination into a feature that is never isolated easily, yet never absent from consideration. Above gamma rays, watch the jet's mood. The orchestra does not share a single conductor. It follows overlapping cues that sometimes reinforce and sometimes pass by one another. A gentle analogy is allowed to fold the wavelengths together. The spectrum is a long shoreline where different waves arrive from storms on different seas. Some are set by local winds, the disk's own heat. Some by distant weather, the jet's accelerations. Some by the shape of the beach dust and reflection. And the total motion at any point is their sum, which looks simple when written as a curve, yet is complicated in the water itself. Calibration is its own quiet story. Absolute flux scales differ between instruments. Cross-calibration campaigns treat 3C273 as both subject and yardstick. Small offsets in 0 points matter when spectral breaks are shallow. Apertures select differently. A wide slit gathers more host starlight. A narrow slit trims it and risks slit losses. Space telescopes avoid telluric absorption that ground instruments must divide away with standards. Only took careful housekeeping to prevent a fictitious kink in a plot from becoming a theory. Only took matching beam sizes to keep the radio core and extended jet from swapping places in the ledger. The uncertainties that remain are invited to stay. Where along the jet are the highest energy photons made inside the broadline region, where external photons are dense and cooling is fast or farther out, where the photon field is thinner and variability timescales broaden. Why does the soft excess cluster in temperature across many sources, when disk temperatures should scale with black hole mass and rate? How exactly does the warm Comptonizing layer keep itself supplied with heat without becoming the corona proper? The answers come in families and in priors, not in certainties, and 3C273 participates in the pattern rather than solving it. Dry observations continue to do their quiet work. Polarization low in the optical when the disk dominates and higher when the jet flares. Colour diagrams that arc along tracks expected for a disk brightening from the inside out. AR locks, steepening as the UV grows relative to X-rays in luminous phases. Mid-IR reverberation that lags the UV by months, marking the inner dust radius where grains sublime and reforms a dust echo that turns the plot into a light travel map. Even the far infrared carries weight. A cool component hints at star formation below the glare modest in this old host yet measurable, when the nucleus dims enough to let the flaw be heard. In assemblies of many epochs, the spectral energy distribution becomes not one curve, but a bundle of curves that translate between states: jet quiet, disk loud, jet loud, disk modest, both tempered, both insisting. The spine of the bundle shows what the source is most of the time. The edges show what it can be when one component takes a turn. Only took time to discover that the average SED is not a thing the quasar ever occupies. It is a statistical truce among moments. The section moves without hurry to the practical uses of such a composite. Integrate under the curve, adopt a bolometric correction, and a luminosity emerges that compared to the Eddington balance, for the reverberation mass implies a comfortable fraction of the limit, neither starving nor overflowing. Use the optical UV slope and the X-ray hardness to estimate how the corona is shading the disk. Use the millimeter peak and gamma ray variability to infer Doppler factors that are independently checked by apparent superluminal speeds. Use the mid-IR lag to draw a dust radius in light months that can be sketched as an inner ring around the nucleus, both a responder and a shield. The whole admits no single diagram that is true in all hours, yet it gives estimates that agree across methods more often than not. Outside the mathematics, the impression is calm a system that speaks across bands without raising its voice in any one of them for long. The ironies are counted once more and let lie. Only took the simplest element hydrogen to mark cosmological distance, yet it takes the whole electromagnetic spectrum to tell how the power is spent. Only took a point that looks like a star to fill detectors from meters-long waves to GeV photons. Only takes subtracting what flares to hear what hums, and subtracting what hums to hear what flares. The night outside the curve is ordinary. Somewhere a millimeter array rides dry air. Somewhere a small optical telescope keeps an automated vigil through thin cloud. Somewhere a detector in low Earth orbit crosses the day-night line and resumes its count. The quasar does not notice that it has been sliced into bands and plotted on axes. It continues to turn motion into light in layered ways. The spectrum, when it is drawn again next season, will look the same in outline and slightly different in detail, because outlines belong to physics, and details belong to weather in the engine. The Lighthouse in Virgo keeps its mixed, Choir and listeners arrange chairs at different distances to catch each part, knowing that no single seat hears the whole at once, and that the whole when assembled is enough. Invisible rails keep the system from wandering. Power can rise, but not without limit. Regions can shrink, but not below what light allows. Particles can be hot, but not so hot that their own radiation undoes them. The accepted fact that grounds this section is steady and sufficient. A small set of physical ceilings and floors, Eddington balance for radiation against gravity, brightness temperature limits from inverse Compton, cooling, and light travel constraints from variability govern how bright, how compact, and how fast a quasar like 3C273 may appear, and those limits, when read together, point quietly to accretion rates, Doppler factors and source sizes that the eye can never resolve. Eddington's balance is the most famous rail. Radiation from accretion pushes outward on electrons. Gravity pulls on protons and electrons together. In a spherically symmetric, steady flow, there is a luminosity at which the two drifts meet in equality. A quasar's inflow is not a sphere, yet the limit remains a ruler that engineers intuition. The measured bolometric output sits at a comfortable fraction of that value, for a black hole mass inferred independently by reverberation mapping in the hundreds of millions of suns. The conclusion is calm, the engine runs bright but not bursting. Disks and winds share the burden. Geometry allows high output without a blowout. Far from the disk, other rails take over. At radio wavelengths, compact cores can seem implausibly bright if one naively divides flux by solid angle and translates to a brightness temperature. Push that temperature much beyond a trillion Kelvin and inverse Compton losses would avalanche the same electrons that radiate synchrotron photons would upscatter them into high-energy bands so efficiently that the radio would quench a tidy catastrophe that the sky rarely permits. The observed solution in 3C273 is gentle, modest Doppler. Boosting from a jet pointed near the line of sight raises apparent brightness and compresses observed time so that cooling limits are respected in the fluid's own rest frame. A flaw appears as well if brightness is too low for the observed variability causality protests. A region that brightens across a day must be no larger than a day of light travel times, a factor for relativistic motion. The clock draws a boundary on the map the telescope lacks. Between ceiling and floor sits a narrow passage the source actually uses. A lesser-known detail lives where radio maps meet theory. The position of the core in VLBI images shifts with observing frequency because optical depth from synchrotron self-absorption falls at higher frequencies. In 3C273, the measured core shift traces T1 surfaces that sit closer to the true jet base as frequency rises. The dependence of that shift on frequency allows estimates of magnetic field strength and particle density on parsec scales without touching the source. From those inferences, a quiet portrait emerges fields of a few tenths to a few Gauss near a parsec from the core particle energies near equipartition, with fields numbers that keep the flow efficient and long-lived. The script moves without hurry through each rail. Eddington's ledger writes in simple units, luminosity proportional to mass. Radiative efficiencies that depend on spin and disk state set how much mass inflow is needed to sustain what is seen. If the fraction of the limit is modest inflow rates in solar masses per year, fall in ranges the host can supply by stellar mass loss, and minor accretion a household economy rather than a flood. Radiation pressure instabilities that once worried thin disk pictures become damped by advection, by vertical structure, and by the steadying influence of magnetic stress. If flicker remains, it sits in the days to months variations already recorded. Only took a bound set by electrons to tell a story about protons and gravity. Only took a fraction of a theoretical limit to infer that a galaxy's slow feeders suffice. Only took a balance written for spheres to remain useful in a system that is anything but spherical. Brightness temperature carries its own arithmetic. The synchrotron formulae, spare and exact, connect. Observed flux, density, size and frequency to a temperature of the equivalent black body that would produce the same specific intensity. Push that number high and inverse. Compton's scattering of the synchrotron bath into X-rays and gamma rays would rapidly cool the electrons, an outcome not observed at the levels such naive temperatures predict. The gentle corrections are familiar now. Doppler factors of a few to 10 suggested independently by apparent superluminal speeds in the same source reduce comoving brightness to lawful values. Equipartition between particle and field energy densities minimizes total energy for a given synchrotron output, and when adopted yields sizes and fields that further tame temperatures. The rails cooperate, none needs to be tuned by hand. A quiet mystery is allowed to remain at this junction because it belongs there. The degree to which jets maintain equipartition along their length is inferred and not measured directly. Shocks reconnection and shear could push regions temporarily away from equipartition. Radiative and adiabatic losses could pull them back. The duty cycle of such departures, whether brief and local or persistent and structural, governs how far inverse Compton rails minimum energy arguments and observed spectra can all be satisfied together. The data allow comfortable ranges. They do not insist on a single path. Variability speaks again in units of distance. Light curve power at a given timescale places an upper limit on the size of the region responsible. In 3C, 273 intraday flux changes at millimetre wavelengths suggest very compact zones near the jet base, while slower month-scale optical drifts belong to disk annuli that carry more area and longer diffusion times. The lags between ultraviolet and optical bands measured in days give radii consistent with disk temperatures. The lags between continuum and broad lines measured in weeks to months give shells and wind layers around the nucleus. Only took clocks to draw rings no telescope can see. Only took the lack of sharpness in a point to become a ruler sharper than any image. Only takes the refusal of light to outrun itself to tell where the source must end. Other rails live in spectra. The turnover between optically thick and thin synchrotron emission, the frequency at which self-absorption yields, sets a size-field flux relation that refuses extremes. Change one too much, and the others must follow. Pair production in the highest energy gamma rays can in principle absorb photons if soft targets are abundant near the source. The lack of deep absorption features at those energies hints that either emission occurs beyond dense radiation fields, or beaming reduces the interaction in the comoving frame. Reflection features in X-rays refuse an inner disk that is both too cold and too distant. Their breadth points to speeds and radii that set another inner rail. Each of these acts as a soft stop rather than a wall. Together they shape a corridor that the quasar follows naturally. The gentle analogy is architectural. These limits are not prison bars. They are the load-bearing lines in a building plan. Place the beams where physics says they must be, and the open space's luminosity-size slope appear between them and stay standing. The three soft ironies keep their place. Only took prohibitions do not exceed this, do not vary faster than that to make possible inferences more precise than any direct view. Only took the threat of a catastrophe that never occurs to reveal motion toward us that we cannot otherwise see. Only took constraints sketched a century ago to guide interpretations of millimetre X-ray and gamma-ray data gathered by instruments their authors could not have imagined. A lesser detail lingers in the radio geometry. The core that observers name is not the physical base of the jet, but the surface of unit optical depth at a given frequency. And because that surface moves inward with higher frequency, multi-band VLBI tracks, a measured core shift that encodes pressure gradients and field scaling along the spine. In 3C 273, those shifts small on the sky and large in implication support a field that falls with distance in a pattern expected for a conical flow and a particle density that ensures the jet remains magnetically guided on parsec scales before kinetic energy takes the lead farther out. The rail housekeeping extends to dust and gas that re-emit and absorb. The inner edge of the dusty region is set by sublimation temperature. Mid-infrared reverberation puts it at light. Months a line past which grains cannot survive the ultraviolet glare. That edge is a rail for geometry, and for radiative transfer beyond it, dust can intercept and soften the light. Within it, clouds are gas only. The broad line regions reach scaling roughly as the square root of luminosity is another soft rail. Increase the continuum, and the emissive zone breathes outward rather than steepening its density or temperature without end. The rails converse across distance, push one and the others adjust until a consistent structure returns. A persistent uncertainty remains in how rails interact at their extremes. Near Eddington, disks may puff, and winds may thicken, altering the same UV that sets the dust edge. At low accretion rates, the coronal fraction may rise until thin disk assumptions fail. In jet flares, brightness temperatures approach apparent limits until fresh Doppler factors or transient structures relax the tension. The source in this narrative, 3C273, spends much of its time in the broad middle, where the rails are guidelines more than warnings. That middle is a comfort constraints agree numbers converge, and different telescopes speak the same language. Down on Earth, the calculations are dry and exact. Equipetition fields are written with exponents and small constants. Eddington ratios with uncertainties that include bolometric corrections. Doppler factors with ranges that overlap those from VLBI speeds. Papers say that the brightness temperature requires boosting, that the dust lag implies a radius, that the hard X-ray cutoff suggests a coronal temperature. The caution in the verbs is not a hedge. It is a style that has earned its keep because rails age well when they are stated as permissions rather than proclamations. The section rests where guided motion ends and habit resumes. Within ceilings and floors, the engine continues to turn gravity into light. The disk glows without bursting. The jet shines without undoing itself. The echoes answer without violating causality. Limits that might have seemed like fences read in practice like measurements. Only took a handful of inequalities to outline a machine that the eye cannot sketch. Only took respecting those inequalities to let the lighthouse shine for epochs long enough to carve cavities in a halo and leave lobes that cool by slow breaths. Outside, the night is ordinary. Somewhere a receiver warms as the sun rises. Somewhere a spectrograph grows dew. Somewhere a space telescope crosses into eclipse and waits. The rails are invisible there too, in streets and tides, in beams and roofs. In Virgo, the point remains untroubled by its own obedience, and the long ledger of constraints closes another page with numbers that fit. Distance in astronomy is not walked. It is inferred rung by rung on a ladder that stays still while the universe moves. The accepted fact that steadies this section is uncomplicated and sufficient. 3C273's distance is not found by parallax or candle, but by redshift placed into a cosmological model with nearer rungs. Parallax standard candles and standard rulers used to fix the scale of expansion so that a single number moves light from wavelength shift to distance. The ladder is calm because it has been built over generations. At the bottom, Earth's orbit around the Sun turns nearby stars into tiny parallax ellipses angles, so small that they require spaceborne precision to keep clean. Those stars carry absolute distances that then teach the luminosities of closer standard candles. A little higher, Cepheid variables breathe light in a steady rhythm, and Type Ia supernovae ignite with a near-uniform peak after careful correction. Both become yardsticks that reach across and beyond the local group. At still higher rungs, baryon, acoustic features and galaxy clusters set rulers in the deep background. When these rungs agree on the present expansion rate, a measured redshift for an object like 3C273 slips into the curve that relates expansion to look-back time and distance, and the result is a luminosity distance that does not require the candle's own brightness to be known. Only took a change in colour to place a lighthouse. Only took the pace of the universe's breathing to position one of its brightest breaths. Only takes one number, the expansion rate, to keep the entire scaffold coherent. A lesser-known detail rides quietly on the ladder's rails. The same quasar that needs cosmology for its distance helps tie together the frames in which other distances are measured. 3C273 serves as a reference point for radio arrays, and as a cross-identification in optical catalogue stitching the International Celestial Reference Frame at radio wavelengths. to the optical frame refined by space astrometry. Because it is bright, compact, and stubbornly present, it calibrates amplitudes and phases for interferometers that then go on to measure the tiny motions that underpin parallax and proper motion. It is a user of the ladder, and in a small way one of its handholds. The irony is soft and simple. The star-like point that cannot be measured by parallax helps build the grid on which parallax is written. The source whose distance is tied to expansion steadies the maps that make the lower rungs clear. The Brightest cosmological lighthouse is also a quiet survey tool with a catalogue number for a name. The section moves gently along each rung without pretending that any single one is sovereign. Parallax writes angles in milliarc seconds. Its reach is bounded but exact, and it tells what a certain kind of star truly emits. Those stars once trusted teach the corrections for Cepheids with specific periods and colours. Their distances then teach the supernovae, whose light curves and colours carry standardisation rules that reduce scatter until the spread is low enough to trust. These supernovae counted across many host galaxies draw a Hubble relation near at hand, a slope that turns redshift into velocity where space-time is close to linear. Calibrated this way, the relation extends to redshifts where nonlinearity matters, and their cosmology joins with matter and dark energy densities, and the expansion rate together mapping redshift into distance. 3C273 sits in this domain. Its redshift does the heavy lift while the lower rungs discuss the length of each step. The physics stays modest. Light leaves at one wavelength, space stretches, it arrives longer. No epics are required, only geometry and patience. A quiet uncertainty remains and is invited to remain because ladders built from many crafts gather small disagreements. Different ways of setting the pace of expansion, nearby standard candles, and distant cosmic background features have not always returned exactly the same number, and the tension between them still discussed and recalculated places a soft fog over any exact kilometre per second per megaparsec figure one might write. The fog is not failure. It is a sign that systematics and methods are being weighed carefully and that the ladder is still being sanded in places where wood from different mills meets. Other uncertainties live in details how precisely standard candles standardise once dust metallicity and host environments are accounted for. How the assumed form of the expansion history shapes distance at redshifts, where the curve bends. None of these alter the essential reading for a low redshift quasar. They merely set the width of the pencil line on the page. The ironies that belong to this quiet ladder keep their light tone, only took what cannot be seen, the change in the universe's scale, between emission and reception to decide where a thing is. Only took a slow breath written into space itself to replace the yardsticks that light cannot hold at arm's length. Only takes more distance for fewer arc seconds and more certainty. A paradox of practice, faraway objects can be easier to place than nearer ones once the expansion curve is trusted. The section lingers on the way the ladder becomes a network in practice. Radio interferometry fixes positions of bright compact sources to milliarc second precision across the sky. Optical astrometry links those positions to billions of stars. Geometric distances inside the Milky Way cascade into luminosity calibrations for galaxies that host supernovae. Clusters and weak lensing sketch the matter distribution that in turn shapes the relation between redshift and distance. In this weaving, 3C, 273 is less a target than a thread that happens to be bright. Its multi-wavelength completeness radio optical ultraviolet X-ray gamma ray means the same source can be pursued by receivers of many kinds, reducing cross-identification mistakes and making it a convenient common denominator when instruments compare notes. The practice remains dry on purpose. Catalogues list coordinates and redshifts. Standard star lists carry magnitudes and colours. Distance scale papers write uncertainties with honest digits. No instrument is asked to do more than it can. Parallax is used where it belongs, candles where they behave, rulers where structure repeats. Each rung stops where it should and passes the work upward. A gentle analogy can stand without pressing. The ladder is not a ladder at all, but tide marks on a pier. The lowest marks are the freshest and the narrowest cut by waves that still splash. Higher marks are older, broader, and stained by different seasons. Taken together, they tell where the water usually sits and how far it has ranged. Redshift is like the water level now, parallax is the lowest wet line. Supernovae are the wide, salt-edged stains higher up. 3C273's place on the pier is read from the modern height, not from the first splashes. Other distances in the same field deepen context without claiming to measure the quasar itself. Intervening absorption systems at lower redshift carve small lines into the spectrum markers of halos and filaments. Their own distances fall out of their redshifts and map a foreground that the quasar's light has crossed. The host starlight, when measured in surface brightness units, can be compared statistically to galaxies with known redshifts. Such comparisons never replace the quasar's own redshift, but whisper that the underlying galaxy belongs to the same distance regime. Mid-infrared echoes from dust at light-month radii are micro-distances that establish scale inside the system, rather than between systems. They are steps within a single rung, not between rungs. The habit of the field is to keep these categories apart while letting them inform each other. Attempts to turn quasars into their own candles have a quiet life at the edge of the page. Some methods use the relation between line width lag and luminosity to propose a standardizable quantity. Others use the shape of the accretion disk's thermal spectrum or the tightness of certain X-ray ultraviolet correlations to argue for a candle beyond supernova reach. The promise is efficiency, the caution is scatter and systematics. For now, a quasar like 3C273 remains a taker of the ladder more than a maker of it, a bright beneficiary of background work done by closer, calmer lights. The ironies can be counted once more without changing weight. Only took unchanging physics to measure an ever-changing sky. Only took a curve drawn from billions of faint galaxies to place a single glaring point. Only takes agreement in the abstract to make a concrete coordinate feel real. Down on Earth, the arithmetic runs at a comfortable pace. A redshift multiplies each rest wavelength by 1 plus z. A cosmology turns that factor into a luminosity distance with assumptions written clearly. A bolometric correction integrates a curve into a single power that sits beside the Eddington ledger. The pages that describe this process are not made to thrill, they are made to last. Instruments age, constants are refined, the steps remain recognizable and usable decades later. When the ladder changes, it narrows its bars and polishes, it does not throw itself away. The section rests where distance joins everything else that has been written. The parallax that could never see 3C273 still matters because it teaches the candles that anchor the slope. The candles that cannot light the quasar still matter because they set the number that tells how far a given redshift travels in space. The redshift that does not care about candles still cares about the number that candles provide. The result is a place in the universe for a point that looks like a nearby star and behaves like a city of engines. Outside the thought the night is ordinary. Somewhere a small telescope measures a parallax ellipse of a star the sun could warm. Somewhere a larger telescope finishes a supernova light curve. Somewhere a spectrum of a quasar writes the same long-shifted lines in a tidy order. Virgo wheels westward with its quiet herd of points, and among them the brightest lighthouse stays a point located not by how big it looks or how bright it seems, but by how long the road has stretched beneath the light it sent. The ladder remains still, the universe slides, the reading is clear enough to sleep on. Between galaxies there is not nothing. A thin, structured medium stretches in filaments and sheets, warmer than the darkness, and cooler than the stars and light that crosses it, arrives carrying small signatures of where it has been. The accepted fact that steadies this section is simple and sufficient. The spectrum of a bright quasar such as 3C273 is carved by intervening absorption systems, narrow lines from hydrogen and metals in the intergalactic and circumgalactic medium, and those lines trace gas in filaments, galaxy halos and cluster outskirts that would otherwise remain invisible. The phenomenon is quiet on the page, yet rich in meaning. Where neutral hydrogen sits along the line of sight, it imprints Lyman alpha absorption. Where oxygen, carbon, silicon and nitrogen are present in specific ionization states, their resonances notch the continuum as well. At high redshift, these marks crowd so thickly that the forest becomes dense. At the modest redshift of 3C273, the lines are fewer and more widely spaced, but they remain sufficient to map a foreground that is not uniform. A lesser-known detail rests in the sightline's neighbourhood. 3C273 lies near the Virgo cluster on the sky, so some of its low redshift absorbers belong to gas associated with Virgo's outskirts, warm, somewhat enriched material in filaments that feed the cluster and in the extended halos of galaxies that move within its pull. Those absorbers appear as Lyman alpha lines and as transitions of oxygen in high states, quiet fingerprints of gas too diffuse to glow on its own. They make a local cartography of the cosmic web with a single bright backlight. The section lingers on method because method is what turns faint notches into a map. High-resolution ultraviolet spectra taken above the atmosphere resolve lines to tens of kilometers per second, separating blends and measuring exact redshifts. Each redshift translates into a distance along the path. Each equivalent width speaks of column density. Each ion ratio whispers temperature and ionization source. Where oxygen in the 6 times ionized state appears. 06. The gas is often warm-hot with temperatures of a few 100,000 Kelvin. Where only HI shows and metals are weak or absent, the gas is cooler or less enriched, perhaps farther from galaxies. By collecting many such lines toward many quasars, observers build a statistical census of where the universe keeps its baryons outside of stars, some in galaxy halos, some in filaments, some in the hotter, more tenuous phase that X-ray instruments sense only at the limit of their reach. Only took subtracting light to see matter. Only took the faintest shadows on a bright source to reveal most of the ordinary matter the universe owns. Only took a single pencil beam through Virgo to sketch structures measured in millions of light years. The physics that allows these sketches remains spare and exact. Photoionization by the metagalactic ultraviolet background keeps much of the low-density hydrogen ionized. Only denser pockets or shielded regions hold enough neutral atoms to write Lyman alpha lines of measurable strength. Metals in various stages reveal both temperature and history. Shock-heated gas in filaments produces high ions. Cooler, denser circumgalactic clouds show lower ions and stronger HI. Because metals arise in stars, their mere presence far from galaxies is a quiet record of outflows, and tidal stripping material pushed or pulled from systems, and then stirred into the web. The line widths, once thermal broadening is distinguished from turbulence, give temperatures. Doublet ratios give optical depths. Velocity offsets between metals and HI tell of structure within a single absorber, not a monolithic cloud but a layered drifting set of parcels. A soft mystery is invited to remain. Even with many lines measured, even with careful modelling, the exact partition of the missing baryons among truly intergalactic filaments, extended hot halos and faint group media keeps a residue of uncertainty. The warm hot intergalactic medium, much discussed, difficult to see, shows itself through O6 and other high ions, and perhaps through very weak X-ray absorption from still higher states. Yet the census depends on ionization corrections and on the strength of backgrounds that vary with place and time. The Virgo Ward sightline of 3C273 helps, because structures there are near and mapped by galaxies and X-ray gas, but helps is not solves. Ranges remain, and the arithmetic stays honest. The ironies travel lightly through the page. Only took darkness to expose structure. The empty spaces are most informative when the source is brightest and smoothest. Only took foregrounds to make the background interesting. What we learn about the universe between galaxies comes from what interrupts a light that is not about those places at all. Only takes a single line of sight to imply a network the audacity kept in check by comparing many sight lines until a pattern repeats. The section returns to Virgo because motion and environment there supply context the sky elsewhere lacks. The absorber redshifts nearest to local values show velocities that reflect both Hubble expansion and the peculiar motions of gas falling into or sloshing within the cluster's extended potential. Some systems near the Virgo velocity display metals at modest enrichment levels, plausible for gas that has met galaxies before. Others are nearly pristine. Galaxy redshift surveys lay a sparse scaffold of galaxies along the same sightline. Some absorbers match those positions in both sky and velocity, a likely circumgalactic halo. Others sit away from luminous galaxies and are better candidates for filaments. The quasar becomes a probe of the interface between cluster and field, not an image of filaments in light, but a detection of filaments in shadow. A gentle analogy fits quiet and exact. The quasar spectrum is like sunlight through a window shade. Each thin slat casts a line, and from the spacing and depth of those lines one infers the spacing and thickness of the slats, without ever seeing the shade directly. Here the shade is the architecture of gas that the universe built, while galaxies assembled and moved. Technique does its unglamorous work in the details. Continuum placement matters, the big blue bump rises and bends, and the true underlying shape must be modelled to keep the weakest absorbers from being mistaken for small ripples and vice versa. Instrumental line spread functions must be measured and deconvolved without inventing sharpness that isn't there. Multiple instruments taken in different epochs must be cross-calibrated so that lines do not shift or deepen because of hardware rather than gas. Only took 1,000 small preventions to protect a handful of molecules of knowledge in every 1,000 photons. Only took the discipline of saying uncertain on the smallest lines to make the sum believable. The absorbers speak too about time. Metals in the web imply that galaxies have been exhaling for a long while supernova-driven winds and tidal processes that move enriched gas out of the places where it formed. The degree of enrichment falls with distance from galaxies. The ratios among elements carry hints of whether Type II or Type Ia supernova products dominate a slow record of star formation history written far from stars. Along 3C273, the mix is varied as expected. Virgo's influence raises the chance of meeting enriched gas. More general intergalactic stretches show planar hydrogen. The distribution of column densities when compared to other sightlines at different redshifts settles into a story in which the Lyman alpha forest thins over time as structures grow and as the background that ionizes hydrogen changes. The present-day universe is quieter in low-column hydrogen than its younger self. The forest has fewer trees near us, and 3C273's spectrum reflects that maturity. A quiet uncertainty lingers around the hottest phase, the one that might close the books on the remaining baryon budget, the warmest, thinnest gas that X-ray instruments can barely grasp. Claims and limits tighten. Stacking analyses and deep pointings push the boundary. The sightline through Virgo is tempting because the path length through structured gas is long. Yet the proof remains marginal where sensitivity ends. The narrative stays patient. Some answers will arrive as instruments improve. Others will arrive when more sightlines are added and the statistics harden. Even without closure at the hottest edge, the pattern already found is a comfort. Galaxies do not float alone. They are stitched by gas that can be weighed without being seen. Clusters are not islands, but low headlands in a continent of matter. The practice reaches beyond absorption. When a strong absorber is identified near a known galaxy, emission line maps of that galaxy. Hydrogen at 21 centimeters, H alpha, O3, sometimes reveal tidal streams or outflows aligned in position angle with the absorber's velocity. A gentle triangulation that turns a pencil beam hint into a three-dimensional guess. In other cases, no clear counterpart appears, and the absorber remains a lonely mark that likely belongs to the wider web. Both outcomes are useful association rights detail. Non-association rights large-scale context. The quasar's role is unchanged. In either case, a lamp held behind the scene so the scene can be read. The section slows and lets the image settle, a smooth continuum slightly blue with thin dark notches that repeat the same small grammar wavelength depth width, pair or singlet. Some lines cluster, some stand alone. A modest train of features near the local standard of rest suggests gas in and near Virgo. Another set farther redward marks more distant foregrounds. Metals where present bring a suggestion of temperature, where absent neutrality and thinness take the stage. Nothing in this portrait pushes, everything accumulates. Only took a single spectrum to carry both the nearest cluster's outskirts and the most delicate intergalactic threads. Only took the brightest nucleus in Virgo's direction to give Virgo's own faint exhalations a way to be seen. Only takes returning to the same object with sharper instruments to watch the forest become a set of named trees. Outside the page the night holds. A satellite slides into Earth's shadow and keeps counting. A radio dish elsewhere traces neutral hydrogen in emission across Virgo's face. An optical spectrograph nods between target and standard. The point that is 3C273 does not know it has been used as a light table. It keeps sending its mixed choir. Along the way to us gas that is not part of it edits the song in narrow bands, and those edits prove that the space between galaxies is not a blank, but a medium with temperature enrichment and motion, a medium that cradles clusters, feeds halos, and remembers where structure has grown. The lighthouse remains at the horizon of thought. The path between here and there, once taken for granted, now has its own atlas. Across the Earth antennas wait in darkness and daylight, each one listening to the same distant point, and together they turn the planet into a single patient instrument. The accepted fact that steadies this section is simple and sufficient. Very long baseline interferometry. Links radio telescopes thousands of kilometres apart so that by recording the wavefront from 3C 273 with atomic clock precision, and later correlating the data, observers synthesize an Earth-sized aperture and draw milliarc-second maps of the core and jet that no single dish could ever resolve. The practice is exact without spectacle. Hydrogen masers keep time at each station, receivers cool, wide bands of radio noise signal plus sky are written to disk with times stamped against the standard kept by the master. When the observation ends, drives travel to a correlator where the streams are slid and multiplied until fringes rise above noise. From those fringes, amplitudes and phases on each baseline enter a ledger called the UV plane, and from that ledger, an image is coaxed by algorithms that prefer the simplest brightness distribution, consistent with the measurements. A lesser-known detail belongs to the method's memory before disks rode. Planes tapes rode them, and VLBI by mail was literal reels in cases. Customs forms, phone calls about weather and shipping, and the first milliarc-second maps of 3C 273's superluminal knots were made from signals that met each other only weeks after they met the sky. The ironies assemble softly around the scaffold. Only took the planet's diameter to draw a line a light year long on a galaxy, millions of light years away. Only took delays measured in billionths of a second to reveal motions that human eyes would never notice in a lifetime, and yet continue steadily for decades. Only took the largest practical telescope ever built to show that the brightest part of the quasar is not the place where the engine lives because opacity pushes the core downstream, and its true base hides closer in. The section lingers on the arithmetic that turns baselines into maps. Each pair of antennas samples one spatial frequency. The Earth's rotation swings that baseline through angles so that tracks curve across the UV plane. More antennas mean more tracks and a rounder synthesized beam. Phases corrupt easily, ionosphere, troposphere cables, clocks, but closure quantities rescue structure. The sum of phases around a triangle, the product of amplitudes around a quadrilateral, numbers that cancel station-based errors and keep only geometry. With these, a clean image emerges, the core compact and bright. The jet one-sided by beaming with components that separate over months in straight or gently curving lines. Fit Gaussians to the knots. Note their separations. A plot of distance versus time gives slopes that look faster than light, because of the angle and the speed already explained. The map becomes a film when epochs are stacked, and the film becomes a ruler for angle to line of sight and bulk Lorentz factor. A quiet mystery is permitted to remain where maps and models meet the exact birthplace of high-energy flares along the jet. Sometimes gamma-ray brightening coincides with the appearance of a new radio component at the core. Sometimes it precedes that appearance. Sometimes it prefers a stationary feature, a little downstream where collimation tightens or a standing shock holds. The timetable is suggestive, not universal. Opacity shifts the radio core with frequency. The site of Compton scattering might sit inside the broadline region or beyond. The film hints. Certainty keeps its distance. The practice extends across bands because the core itself slides with wavelength. At higher frequency optical depth falls and the apparent origin of the jet moves upstream. Measure the core shift between say 15 and 43 GHz, and pressure and magnetic field gradients along the inner jet reveal themselves without any need to touch them. 3C273 has served both as target and as calibrator. In such work, its brightness stabilizes solutions for weaker neighbours, and its own shifts small on the sky and large in inference argue for a magnetized conical flow that keeps near equipartition on parsec scales. Only took the way a picture changes with colour to weigh fields that cannot be seen. Only took the refusal of a core to stay put to show that a map is a surface, not a place. The craft is as much earth as sky. Wet troposphere delays bend the phase. Total electron content over each station disperses it. Pressure, temperature and humidity logs keep the solvers honest. GPS feeds corrections. Clocks drift by nanoseconds and are herded back by calibrators observed every few minutes. Some campaigns use phase referencing nodding between 3C273 and a nearby compact source transferring the phase to sharpen the image and to lock positions between epochs. Global networks lengthen baselines, Europe to North America, to South America, to East Asia. The dotted great circles becoming chords in an instrument that sleeps where it is cloudy and sings where it is clear. The resulting beam changes its shape with configuration. Observers deconvolve that shape, but always with care not to invent sharpness that the data cannot support. The discipline is to accept what the UV coverage allows, and to state the rest as limits. The jet's internal life appears in polarization as much as in total intensity. Electric vector position angles line up along the flow or flip across shocks. Rotation measures rise near the core where magnetized plasma is dense. Gradients across the jet hint at helical fields or sheath spine structure. In 3C273 sequences of millimeter polarization maps, sometimes swing through tens of degrees as a new component passes a standing feature. Each swing a whisper from the magnetic architecture at parsec radii. These patterns are not merely decoration, they are the only practical probe of field order, this close to launch in a source too distant for horizon-scale imaging. A gentle analogy is allowed. VLBI is not a camera, but a loom. Each baseline is a thread. Earth's rotation passes the shuttle. Closure quantities tie knots that do not slip. The finished cloth and image shows texture only where enough threads have crossed. Where the weave is thin, the cloth is honest about its holes. Uncertainties linger where they should. Amplitude calibration has histories and weather. Absolute position between frequencies needs more than cleverness to keep. Dynamic range is finite, and the brightest core can leave side lobes that masquerade as structure if not controlled. Some knots accelerate or bend between epochs. Some fade into the beam, some split. Distinguishing true motion from changing illumination in standing patterns taxes the patience that the method relies on. The answer has always been cadence return, 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 until trends outrun noise. The ironies continue to be soft and useful. Only took continents to notice that a knot the size of a few light years shifts by a fraction of a milliarc second each season. Only took antennas staring at the same point to build a picture that looks like a line when in truth it is a set of differences arranged with care. Only takes a source so bright that it can blind single dishes to give interferometers their best subject. Brightness that is a nuisance in one practice becomes a gift in another. The maps feed other ledgers. Proper motions provide Doppler factors that agree with those required to keep brightness temperatures lawful. Component birth times line up with millimeter flares, and sometimes with high energy peaks, providing causality checks on models for the origin of gamma rays. Stationary features suggest recollimation shocks that help hold the beam narrow, long enough for kiloparsec scale radio structure to bloom. Farther out, where VLBI hands the torch to connected element arrays with shorter baselines, the jet widens and dims into plumes and then lobes whose pressure against the circumgalactic medium writes cavities seen by X-ray telescopes. A single Earth-sized eye begins a chain of inferences that ends at scales larger than some galaxies, and all of it begins with clocks and patience. The daily life of the method is ordinary and therefore beautiful. Schedules avoid storms, technicians swap cryogenic heads, the station's bias jumps and is found by a human who knows what wrong looks like in a strip chart. The correlator room is cool and loud, fringes at first do not appear, and then after a delay set in is nudged by microseconds they do. Fringe found used to be a shout, now it is a log entry. In either era it is the same relief because a delay that lines up means the Earth has been measured well enough for the sky to hold still. The maps of 3C273 accumulate in libraries' contour plots, with small beams drawn in a corner component labels that are letters more than names, axes in millix seconds and position angles. Look across the years, and the jet walks outwards step by step, as if the planet's rotation were a clock for a filament millions of light years away. There is no forward motion in the narrative beyond that walk, and no need for any. The instrument keeps its habits, the source keeps its. The section rests with the image that does not change even as the images do. Antennas under snow and under desert heat listen to the same point. Oceans between them turn into baseline lengths. Equations knit their results. A line appears that was always there, and yet requires the Earth to be a tool before it can be seen. The quiet uncertainty's exact launch physics' true core location. The birthplaces of the highest energy photons remain in their places, leading forward without hurry. Outside, night rolls from one station to the next. Somewhere a dish slews to a calibrator. Somewhere another enters maintenance and leaves a hole in the UV plane that software will acknowledge but not lie about. Over Virgo, the bright point is the same. In the archive 3C273's jet advances one more millisecond in a plot that another student will measure against a ruler that someone else left in a drawer, and the Earth continues to be the lens that lets a line in a remote galaxy become a line we can draw. Time keeps several ledgers open at once, and 3C273 writes in each without hurry. The accepted fact that holds this section steady is simple and sufficient active galactic nuclei do not shine at a single unbroken level forever, but cycle through episodes of stronger and weaker activity. Their jets and lobes age radiatively, while the central engine's fueling waxes and wanes, so that what looks steady tonight is an average across many clocks. The evidence is quiet and cumulative. Long optical and ultraviolet light curves drift by tens of % over months to years. Radio cores brighten and dim on their own schedules. Millisecond components appear and recede. Far from the nucleus lobes steepen in spectrum as synchrotron and inverse. Compton losses cool their electrons, and the steepening itself is a clock that counts in millions of years. A lesser-known detail rests in certain relics that astronomy has learned to notice ghost cavities in X-ray maps, and faint outer radio rims around some double sources. Double-double structures betray older jet episodes now faded, while fresher inner pairs ride inside them. Even when a given face-on quasar like 3C273 shows no textbook relic shells, the class as a whole teaches that lighthouses do not burn uniformly, they tend to return. The soft ironies gather without emphasis. Only took a point that looks unchanging to display under patient watching a temperament that never quite repeats. only took the oldest, faintest features to keep the best time, only takes an engine invisible to any camera to leave the clearest marks at the system's outskirts, where energy accumulates and remembers. The section lingers where plasma grows old. Electrons that once radiated in the jet and lobes lose energy through synchrotron emission in their magnetic fields, and by upscattering background photons, especially the cosmic microwave background. As the highest energy electrons fade first, spectra, steepen breaks, migrate to lower frequencies and maps drawn at multiple bands. Contour and age pattern, younger near sites of fresh acceleration, older in the broader plumes. Buoyancy adds a slow motion to the picture. Cavities inflated by past jets rise gently through the hot atmosphere of the host's halo. Edges soften, filaments of compressed gas curl. None of this requires a new outburst to be dramatic. The after effects of long patient power are sufficient. In the nucleus the clocks run faster. Accretion rates drift with the supply of cold gas, and with how magnetic flux piles at the inner disk. The corona warms and cools in step with the seed photons. The jet's base responds to geometry and spin as much as to feed. Light travel delays link these layers into a modest choreography. A rise in ultraviolet today, a change in broad lines. Weeks later, a millimetre flare later. Still as a new component clears the most opaque inner reach, and sometimes high-energy brightening that coincides with the crossing of a standing shock downstream. No single timetable is sovereign, several keep accurate time at once. A soft mystery remains where it belongs, the length, regularity and triggers of the duty cycle. Does the engine prefer many brief episodes or fewer long ones? Do bars, minor mergers or stochastic cold clouds set the rhythm, or is the gatekeeper the magnetic flux supply that toggles a magnetically arrested state on and off? The literature offers ranges rather than revelations, duty cycles from a few percent to tens of percent, across cosmic time episodes that last from less than 1 million years to tens of millions. Enough to draw a family portrait, not enough to name the habits of each child. The portrait broadens when the sky is taken as a census rather than a single object. Quasar numbers swell at redshifts of 2 to 3 and thin toward the present, a demographic that says black holes did much of their radiative growing when the universe was a few billion years old. The integrated light of that era, folded through efficiency, matches the present mass density of dormant black holes in local galaxies, the Salton argument, so that tonight's bright points are members of a population for which bright phases and quiet phases together account for most of the mass that hides in galactic centres. In this arithmetic, 3C273 is an outlier by brightness, but not by role. It is part of a story in which most large galaxies have hosted lighthouses, and most lighthouses have drifted from storm seasons into calms. A gentle analogy helps. Kept at low volume, the system breathes in 2 ways at once. There is a shallow regular breath, the disks flicker, the jets knot by knot advance, and a deeper slower breath, the inflation and fading of lobes, the rise of cavities that takes many millions of years. Both breaths are audible in data, neither needs drama to be believed. The 3 soft ironies return easily. Only took flicker noise by another name to reveal mass with precision. Only took fading the vanishing of high-energy electrons to reveal time with grace. Only takes the long drift of a lobe to prove that the bright fast core is the part least suited to keeping the oldest memory. The duty cycle folds back into the host and its surroundings. Feedback. A quiet word for a long exchange appears as cavities that temper cooling in the halo, and as filaments that record slow stirring. Tempering the halo in turn moderates future fuel to the centre. No single switch flips the system. Rather, a series of gentle checks and balances spreads cause and effect across scale. If the nucleus spends a while below its long average, the slow clocks continue without complaint. If it brightens, the immediate neighbours answer first, and the outskirts notice only later if at all. Along some sightlines across the sky, ionization echoes have even betrayed changes that the nucleus made 10 or 100,000 years ago by lighting remote clouds that still glow, though the central source has since dimmed. Such echoes are rare and not claim on 3C273. They are reminders that light itself can be a store of memory when geometry provides a path with extra length. The practice of reading these times does not ask for images alone. Spectral curvature in the lobe's curvature, in the jet's knots, and maps of polarization that preserve the direction of fields after shocks have passed, all of these act as diaries. Buoyant rise speeds inferred from cavity positions and halo temperatures add lines to the same diary in different units. Even non-detections, when deep limits show no outer older rims, say something plain any earlier episode was long enough ago, or faint enough that today's instruments cannot pull it from the cosmic background. The uncertainty that remains is patient. The precise balance between spin extraction and disk launching at the base may change the cadence of jet episodes. The long-term supply of cold gas may be set more by the circumgalactic medium's weather than by the host's interior. The angle between black hole spin and inflow may wander, and with it the jet's aim across centuries to millennia. These are changes that VLBI movies cannot see, and light curve campaigns cannot time. They are the kind that show up as gentle bends or as asymmetries in low pressure long after the inner choices have been made. The narrative keeps the pace that the subject sets. There is no crescendo. A bright point continues to appear in Virgo star-like, at a glance richer in every measurement. Near the core, the fastest clocks turn hours to days. Around the core, the echoing gas keeps weeks to months. Along the jet knots write years. In the lobes and halo, millions of years unspool. The ledgers do not balance in any 1 hour. They balance in averages that a single lifetime can help measure but cannot complete. The 3 dry observations that have kept their place through this script keep it now. Only took the absence of spatial resolution to invent temporal resolution of surprising delicacy. Only took the threat of physical limits, Eddington brightness temperatures pair production, to become the overlaid grid that makes interpretation precise. Only takes consistency across independent methods to make confidence feel like rest, not like insistence. If there is a last image to set before the wind down that follows, it is not a picture, but a mood of scales nested inside scales. The accretion disk remains a slow storm that never makes a sound. The corona is the thin hot weather above it. The jet is a courier that carries away angular momentum and power. The lobes are reservoirs that forget the details of launch and remember only the totals. The host is a hill of old starlight. The halo is a warm lake. The surrounding web is a set of long, nearly invisible roads. Along one of those roads, the light we see left when different ice lay on different lands, then threaded a cluster's outskirts and crossed a field of galaxies until it found this glass. The beacon will brighten and fade in measures small to us and large to itself. The jet will send another knot that a new student will mark in a plot. The lobes will steepen a little more. Everything that matters in the system continues while the telescope caps are on, and while they are off. The lighthouse does not devour fuel in flames. It rearranges motion into light pauses and continues grows and rests, all within rails that keep it lawful, and within a building plan that can stand for epochs. Nothing here needs a conclusion. Night air gathers on leaves. Somewhere a correlator idles, somewhere a spectrograph cools, somewhere a notebook closes. In Virgo the point remains. The long drift of cosmic time accepts it without comment, and the light that left long ago keeps arriving a steadying presence that has already outlived and will outlive every instrument that reads it. Night leans closer. The page grows spare. Air cools against glass and a dim hush settles over rooms and rooftops. The sky holds its quiet pattern, faint stars and a single bright point that does not waver. Breathing evens. The long scales soften into one present moment that asks for nothing more than stillness. Distant light arrives, as it always does, gentle and exact, crossing the dark without a sound. The mind lets its edges smooth. Numbers loosen their grip and drift to the margins. Instruments rest, lids closed, mounts at ease. The world narrows to cool air, a steady heart, and the small weight of blankets. Above, space keeps its patient order, not urging, not insisting. The bright point remains a bright point. It neither comes closer nor fades away. It simply is. Thought grows slower, like silt settling through water. The sky's pale weave becomes softer still, a quiet fabric stretched over an endless frame. Time thins. Waves on some far shore arrive shallower and farther apart until they are only a sheen, and then a memory of a sheen. Breath meets breath and finds the same pace each time. Gravity holds without effort. The room is steady, the floor is sure, and the night is kind. No measures are needed, no answers. Only the drift downward, as gentle as dust, as unhurried as cooling stone. The bright point waits where it has always waited, not calling, not receding a single mark that lets the darkness feel complete. Eyelids lower, the last light gathers and separates into quiet grey. Overhead the sky carries on calm and exact as the body yields to sleep and the mind loosens its hold on the hour. Nothing asks for attention now. Nothing presses. Stillness arrives and stays.